Welcome back. We are on to chapter 3 of our journey to building our first skill, 8-bit stories. The skill that is going to write stories about your family on epic adventures. Let's do a quick recap of what we've gone through so far, and then let's get started. So chapter 1, we built out our dashboard. That is our root skill view controller. We ensured that we needed login. We rendered a card. We put some header images, put some buttons. We played around a little bit. Easy peasy. In chapter 2, we got into feedback. We rendered a dialogue. A dialogue is just a card view controller. We set some content, we dropped in a form, and we created our first event, submit feedback. All that did was emit another event called send message, but it's baby steps, right? Now we're on to chapter 3, your family values. So there's going to be a lot of stuff we've done, so some of it should go pretty fast, and then there's just a handful of new things. In this case, we're going to start with a redirect. So we're going to get into some basic routing. Then we're going to render a form. We've already done that. That's going to force us to deal with some schemas and some form view controllers, and we've done all that. Then we're going to create an event to save your family values. We'll probably just call it save family values. Then we're going to do something a little bit different. Instead of in the listener emitting an event, we're actually going to persist the data. So we're actually going to get into some data stores. What are data stores? Well, simply put, it's our database abstraction layer. It's how we're going to persist data, load it, update it. We have a few adapters available, one for Mongo, one for Postgres, more adapters to come. And something to keep in mind is the data store layers, it is not an ORM. It's simple, basic CRUD operations and the ability to make raw queries. That's it. So we're going to get to persist some data. Oh, and a good call out. In our tests, it uses an in-memory database. So that should help us go really fast. Then we're going to create another event to pull the family values back out. That way, when you revisit the form, it's filled out for you. Okay, I think that's it. Let's get rocking. Let's make it so when we click on the family values button, it redirects to our family values skill view controller. And that's kind of the end of that sentence. Just start there. Easy peasy. So I'm going to jump back into VS Code. I'm going to hit Command P and type root test. And let's just add our next test. Let's go up here. Let's go to test. Protected static async. Clicking family values button redirects to values skill view. That's a pretty long name. Whatever. Pretty clear. We don't even need clicking. Just family value button redirects to value skill view. So how do we do that? Well, let's start with the failing test. I'm going to go await and use the VC assert, the view controller assert, and we're going to type dot. And then I'm just going to type redirect because I can never remember exactly what it is. And here are all the redirects. Action redirects. What's the first thing? Oh, it's options. So I'm going to do a little curly single quote. We have an action, a destination, and a router. So let's start with the action. What is the action that triggers this redirect? And in this case, it's a click. So I'm going to put a callback function. And I'm going to go interactor dot click button. The first thing is what? The view controller. So this dot card VC, because we want to click the button in the card in the skill view. If I'd have done just that, this dot VC, this is the root skill view controller. There's in fact no button on that. The button is in the single card that we're rendering, which we just called card VC. And then I'm going to hit comma. The next thing is the button's ID, and I believe it's called values. Hit save. That's not going to work, right? Because there were a few other things that were required. Missing the router. So let's go router. And to get the router, we're going to use the views fixture. And that's this dot views dot get router. And then let's put in the destination. Where do we want to send them? So destination is an object. The first thing, if we do the single quote, we have the ID and the arg. So when you're redirecting, The equivalent of query parameters, we just call arguments. So you pass the args to the skill view controller. But for now, we're just going to pass an ID of the new skill view to which we want to redirect. And we're going to call it 8-bit stories.apply just values. All right. There's our assertion. Let's watch that fail. Clicking failed because the button values does not have an on click. So I'm just going to solve this one step at a time. Let's go into root.svc. Let's go into our button. Here is our values button. Let's go on click. This handle click family values. Now this doesn't exist yet, so I'm going to create it. Private async handle click family values. All right, that's it. I'm just going to get that test to pass. Let's see what's next. Bam, I expected to redirect it, but was not. Okay. How do we redirect? Well, we need a router. You do not get a router on your skill view. So I'll go this dot router. There is no router. So in fact, if I just do this dot, you can see what's on here. There are some things here, but there is no router. We have to actually get the router. This is going to bring us to the skill views life cycle a little bit. So let's jump into that in the documentation. I'm going to go here. I'm going to say help docs. I'm going to go concepts and then views. And let's scroll down and we are looking for this. So check this out. This is just a little bigger. Skill view lifecycle. So here's what happens. When you load a skill view, you pull it up and the first thing that loads by default is your root skill view controller. That gets pushed onto the stack. Then what happens is the skill view navigator that's managing the stack calls these methods on your skill view in this order. So first it calls will focus. So you can implement the will focus method to perform some operation just before it comes into view. Then there is get is login required. So if you recall, when we went into our root skill view here, Command Shift O, get is login required, we return true. So that gets called. Then get scope is called. So in this platform, things can have 3 or I guess like 5 or 6 various scope configurations. It can be global, which means you're just pulling it up. That's what we're doing for 8-bit stories. It can be organization. So that means that the skill has to be installed at an organization and that all the operations you're performing are scoped to that organization. This is what will allow you to have a skill, install it at multiple locations, and then eventually monetize those skills with the marketplace. A scope can be also a location. So skills get installed at the organization level, which makes it available at all that organization's location. But when it's scoped to a location, all your operations get scoped to that location. So this allows you with multiple locations to scope those operations in a way that protect you from having the team at one location impacting what's happening at another one. And then in addition to that, there is an employed flag. So when you return scope of organization and employed, it's just an array of strings that match the types, an array of string literals. Now your skill will require someone to have a role that is based on a role that is indicative of a person being employed at that organization or at that location. And when we get it, we'll get into some roles. Actually, we're probably not going to get into any roles in this this tutorial on this walkthrough, but you can check out the documentation and see how roles work and all the different role bases that all roles are based on. For this, though, we're just going to ignore scope. It's a long-winded thing for a thing we're just going to ignore, but I do think it's worth at least touching on. So when it does come to the point where you want to create a skill for production use and you want to monetize it and you want somebody to pay to install it and then have it perform operation scope to a location or an org or only for people who work there or only for people who are guests, it will come in handy. Then after this, what's not represented here because it's not part of the actual skill view life cycle is the skill view navigator will take the scope, will take the login requirements, and then will prompt the person who's there to either log in, and then if they work there, let them in. If they don't work there, not let them in, depending on how you've got it scoped. And that ensures that by the time your load method is called, everybody qualifies for the login requirements and the scope requirements. So in our case, since we only implemented get is login required, we set it to true, you will not be able to load the 8-bit stories root or any skill view controller until you're logged in. So what'll happen is you'll see it start to load in the background. The cards will drop in, but since load's not called, none of them will be loaded, which we will control that when we're implementing our skill view. And then once they log in successfully, then load is called. Now load is what we're going to be working in because that's what receives a lot of the tools that we need for redirecting, for authentication, authorization. It's the properly configured load options, we call them skill view load options, that match the criteria you've set in the get is login required and the get scope. Then after load is required, we get did focus, so you can run some operations later on the did focus. Now, this is all happening when our root skill view loads. When we do a redirect, what ends up happening is we push a new view on, and then the old one gets popped off. And then it gets called with will blur. Then the new skill view runs its will focus, get logged in, get scope, load, did focus. And then on the view controller that's being popped off, the skill view controller, it calls did blur. So you can run some operations before it's being hidden, then after, and then destroy. And in destroy, you're expected to clean up anything that you've set up. You don't have to do this too often, except when you're, for instance, setting up maybe some listeners on the front end, and we want to remove those listeners so they don't fire off in the background or they're not persisted in any way. We don't have a leak of any kind, and we will get into that when we do some story generation. Okay, that was a lot, but really what we need to know for this is in order to get the router, we need to implement the load lifecycle method. So I'm going to say public async load. So we've got that. Now we need to properly declare it. So we'll say options, and the type is skill view controller load options. So see how I type skill v colop, enter. Now we're going to get the router out of that. So I'm going to say const router. I'm going to destructure it out. You can hit dot here to kind of see everything. So we've got the args. So remember, when we're redirecting, we can pass arguments across. That's one way of passing and maintaining state. We can also create objects that are in singletons that are available in each skill view. We have lots of options. Args is one way of doing it. And again, you can just think of it as a query string. The authenticator, this is going to tell us if someone's logged in or not. In our case, because we set get is login required to true, they will be logged in. This is also going to let us do things like get person. So we can get the logged in person, or clear session if we want to log them out. Don't be a jerk about that one. Now, what else? We have the locale. So this comes with, and this is our support for time zones and currencies, things like that. So we made it really easy for you to work with time zones. And for the most part, you don't even have to worry about it. The time zone will either be set to the person when they're logged in. It'll default to the browser's time zone. Or a person can go into the profile skill, so profile root, and set a time zone. Or when they're creating an organization, they can set a time zone. And when you're creating a location, you can set a time zone. And so what can happen is you can have your time zone set to, in my case, Denver, but I can be viewing the location of an organization in Florida, and it will use the time zone of the location in Florida. And if you think about why, it's because when somebody's looking up the store hours or trying to book an appointment, they don't want the time in their time zone. They want the time in the location's time zone. And I've made this mistake before, and people have come and booked appointments and done things while on trips, and then came back and showed up at 9 a.m. and be like, well, your appointment's not till 11. And they're like, no, I selected 9 a.m. Here's my confirmation. And it's like, oh, you were in a different, it was 9 a.m. in the time zone you were in. So we're very careful to always show the things in the time zone that is relevant to the person doing the browsing. Again, for the most part, you don't have to worry about this, but you can get the time zone offsets. You can set the time zones. You can actually do this and listen in for time zone changes. Nothing that we have to worry about here, just lots of flexibility there. Here's the router, which we're going to destructure there. Here's scope. So if I hit scope and then I go dot, look at this. I can get the current location, I can get the current organization, or I can set the current location or organization. So in the front end, if I were to say this skill is scoped to an organization, meaning it has to be installed there and everything I'm doing is scoped there, when I call get current organization, it will bring me the organization that they're currently using. And Heartwood manages all that for us. So if I click on a skill that requires an organization, Heartwood's going to pop up a selection dialog and essentially ask, which organization are you browsing for? Now, if someone's only like, let's say, part of one organization, it'll auto-select it for them. But if someone's browsing between businesses, again, this is a multi-tenant system with multi-location support also. So if we're scoped to location and I click this store, it's going to pop up and say, which location do you want to browse? And then that gets set here in the scope. And then what was the last thing here? Themes. So if you want to override the theme, which you're probably going to want to do as part of 8-bit stories, maybe we add a little bonus thing about that. And to make it look, well, the way we want it to look. Okay, again, that was a lot, but for now we're really focused on the router because we want to redirect, but we don't want to redirect as part of load. We want to redirect as part of handle, click, family values. So let's just use the view controller state to track the router, and then we're going to redirect in that. So I'm going to click this, and I'm going to go command period and go declare property. So I'm going to get private, and it's just type router out of Heartwood view controllers. Super simple. Now let's go into handle, click family values, and let's go await this dot router dot redirect, and it's going to ask us for an ID, and we're going to go 8-bit stories dot values. Now, this is going to be mad at us because this router, well, let's look at this. See how this is mad at us because we're not setting it in the constructor or in the declaration. So I'm going to make this optional, which is going to make this optional. That's one way of handling this. I could also go bang and then no longer need the optional. And that's fair too. I don't really have too much of an opinion. It's just once you understand how this stuff works, it's not too big of a deal. So now do you see we're still not there? Why are we not there? Well, if you were paying attention very carefully, which I don't know how you'd catch this without just kind of knowing, where are we loading our skill view? We've constructed our skill view here, 8-bit stories root, but we're not loading it in any way. So we actually need to load the skill view. So to do that, we need to go await this dot. We go to the views fixture dot load and we pass it our skill view. And this is going to load the skill view with all the expected options, the router, the authenticator, all those things that we went through here. Because you don't want to have to construct that and set this up. That'd be super tedious. You just want to load and have all of it behave as if you were in a production environment. All right, look at that, new error. Couldn't find a view controller called 8-bit stories.values. Try one of the following. Here's all the skill views we have. Or run spruce.create view. I'm going to do that. I'm going to control space, type create.view. And we're going to create a skill view controller, and we're going to call it a values. And we're going to let that run. Sweet. File, values.vsc, updated, views.ts, used to export your controller chartlet. So let's quit out of that, jump to our test reporter, and we are passing. Let's take a look, and let's see how this works. So I am starting fresh on my setup here. So I'm going to hit Control Space. I'm going to type watch views. So I'm going to let that go. Build, importing, found, connected to Mercury, waiting for events. I expect it to say, there it is, built, registered, watching for view changes. So I'm just go back to the test reporter, jump back to this space, close out the help docs, go Command-Shift-N, type, I might have closed out it too much there, type 8-bit, go to 8-bit root, hit root, okay. Let me close this out. So we just have this one window. And what are we doing? We're typing family values. That's it. Well, there's nothing there. And we have no navigation, so we're kind of stuck now. But that is our redirect. So to quickly summarize, we had to assert a redirect, which required us to implement the load lifecycle event, which you can go to help and check views and see the skill view controller lifecycle. But in order to tie it all together, we actually also had to load the skill view. We had to run it through some of its lifecycle. Now, before moving on to the next step of this, which will just be rendering a card, let's do a little cleanup. See this click button? I would rather minimize the amount of dots in here. Is just the heuristic I use. So I'm going to select this. I'm going to say button. Then I'm going to select this, and I'm going to extract your method. I'll say click button. Bring this back here. I'm going to change this. Watch this. This click button. That's going to allow me to cut down on an argument. Save. And then the next thing I'm going to do, just to get maybe you could call me out for getting a little bit ahead on this, is I'm going to select load. I'm going to hit Control-Shift-R. I'm going to say extract a method. I'm just going to call this load. Now it's super clear. This.load and then VC assert action redirects. We click the button values, pass it the router, pass it the destination. We are good. Sweet. Okay. Now before rendering a card though, let's create a new test focused on the values skill view. So we're going to get out of this root skill view test and add a new test. Before we do that, though, I want to spend a little time, just a second, organizing our behavioral tests, which essentially in this case just means I'm going to right-click, go new folder, and type values. And then I'm going to put everything family values related in there. So probably our listener tests and our view tests. And then we'll create the equivalent out here right now. So I'm going to right-click and go values. So we've got our view controller, which is empty, so I can just delete that for now. We've got skill view controllers, root, and values. Let's go to values. So I think a good question is like, what do we do with the root skill view? And what I might end up doing is just creating a folder in here called root and put all of our root related functionality in there. That's kind of up to you. There's, again, this is balancing that like line between dogma and discipline. Got feedback. Error. Okay. So now that that's done, I'm going to hit Control Space again. Control Space again. That asks me to restart the task. I'm going to run sync views. Anytime you're moving around view controllers, the IDE should do this for us. And if you did see it did, it said skip files 1. But I still like to run it anyway. Sometimes VS Code's like, want me to update that for you? I'm like, yes. And it's like, too bad. And sometimes you just don't know until stuff breaks. But again, that's why we trust the tests, not the types or anything else, or even the IDE, especially not the IDE. Okay, let's do our values skill view test. So I'm going to Control Space, hit enter, create a behavioral test and call it values skill view. His name. I'm going to put it inside of the values directory and I'm going to extend the abstract 8-bit test. If you didn't catch on previously, just all of our tests are going to extend this 8-bit test, almost all of them. I can't think of a reason why we wouldn't. And then again, this is just going to hold our helpful utilities, fixtures, whatever we're using repeatedly. So let's see what's in there now. I can't even remember. If we hit Command P and I type 8-bit test, there's abstract 8-bit test. Oh, and it looks like it's just our event faker. That's totally fine, but it's really nicer, more nice, less tedious than having to construct it every test every time. So that being said, let's make sure it renders card VC. So let's go const VC equals this views.controller 8-bit. We're going to do values. What you can do also is if you know the namespace of your the view or the skill you're trying to access, you can delete and retype the period. And that will also kick in and tell us it's at least in VS Code. I can't explain exactly why that does it, or if you were typing here, it's not going to do it. Not going to do it. Type dot, does it. So explain that one. Don't, this is not working. You know what? I'm going to get rid of the cellular test. Just lots of Command Shift Ks here. Let's go. VC assert. Skill view renders card. And we pass it our skill view and an optional card ID. Oh, it's not this. It's this. I'm not going to check an ID. It's just going to render one card. But if we jump back to our wireframes, we have one card with a form. So we're just going to do one card. Expected your skill view to render a card, but it did not. Very fair. Let's go values.svc, value.svc, and let's create our card. This card vc. Oh, remember, because we're in a view controller, we have the controller factory method available to us much quicker. We're going to pass the values. I'm not going to pass anything to. No, let's just for now. Let's get the header in there. Again, we're not going to. No, we're not. Wait, it's a card. We're doing a card. What was I thinking? We're not going to test against or do any assertions against titles. Let's see. How do we have it looking here? Your family. Okay. Your family. We're not going to do any assertions against some of this presentation. We can if we need to. And generally, and I've done it when, like, again, switching something in the UI switches the copy or the way something looks specifically, then I'll go and do some assertions against it. But I really hate the test breaking because someone's like, can you change the label on that button? Oh, I'll break it, everything. That was bad. I'm bad at impressions. There we go. What do you think? That should just pass, I think. You can see I got a problem, so I'm going to hit Command K P. If you've done my shortcuts, it's like this is not used. I'm going to hold Option and hit Delete just to delete a word. You can actually leave that comma in here and just hit Save. Once you get the hang of this linter, you're just never, ever, 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 ever going to bother formatting things yourself. It's just waste of time. Let the linter do it for you, and then let's fight about something else. Not tabs and spaces or indents, or not just. Who cares? I don't know, some people care. Command R to refresh. Well, that didn't render. Let's go back. See, oh, we're not watching anymore. Watch. Views. So that change just never got carried over because we're not registering our changes. Now I should be able to refresh. Come on. There it is. Your family. Things are a little bit slower than me. Sweet. Okay, next step. What is it? Let's render a form. Well, we've done this before, right? So let's do it again. Go to get that muscle memory. Projected static async renders, or card renders form. BC assert. No. Form assert. Again, you want to know what all assertion libraries are available. Just go to the concepts views section of the documentation. And let's do card renders form. And let's pass it the view controller. So this dot, you know what? I don't want to have to construct this view controller again, the skill view controller. So let's move it to type static async for each. Wait, super data for each. Then let's change this. Whoops. Let's change this. I'm gonna option up there. This over. I'm gonna go here and period declare. It really wants that awful import statement inline. We're going to say no to that. We're going to choose love. Wait, seriously. Okay, the card renders form. We need to get the cards. So we're going to go this.vc, which if I hover over this view controller is actually our values skill view controller, not the card. So obviously we're going to type get card. And that's going to fail because we need a test double. Now, I might change this up a little bit because we did a spy last time. Maybe we do something else this time. Let's just use another spy this time, and then we'll get some opportunities to use mocks or stubs or some other type of test double later. So for now, though, we just at least need this to function, this method to exist, and to actually return the card VC property on the value skill. So let's go class spy values skill view extends values controller. You notice on the spies, I don't tend to type out view controller the whole way, or it's like I'll just say like family card versus family card view controller. You can be more verbose if you want to. I just don't think it adds any value. I think it makes sense that the files that we're generating and that the system uses are verbose, so we avoid any potential name conflicts. But for the test doubles, I'm not really concerned with the putting the word controller in it. Okay, so let's say public get card VC. I want to say get card VC. I do like calling out that these are view controllers, and we're going to go this dot card VC. Now this is going to get mad at us here because it's private. So command click, option delete, protected, save, command W. Now let's drop this into the view controller factory to replace the values skill view controller that's there. So this dot use dot set controller. It's 8-bit dot values, and let's pass it the spy. Da-da-da. Sweet. Well, couldn't find a form. That's correct. I would like to get rid of this typing though, because as we saw before, this thinks is typed as a value skill view, and we actually want to do it as a spy. So I'm just going to drop spy in there. Now this is going to get mad at us because the view controller factory is telling the type system it's returning a value skill view controller, not a spy values skill view. But it also lets us typecast. So we're just going to do that. Typical type of extension override. All right, we don't have a form. We should do a form. Let's jump back into root. No. Value skill view. And right above this card, I'm going to go with this dot form VC. It was this dot controller. And we're going to say form. And now, because forms have more sophisticated typing, and frankly, I just couldn't get the typing system to handle the factory pattern and the sophisticated typing all just at once. There is the build form utility function, which literally just returns what you pass it. But by declaring it this way, we get much better, more sophisticated typing. So let's go build form. And what do we have? A single quote. We need a schema. So we're going to say build schema. And a schema's got an ID. And we will call it family values form, I guess. We'll give it no fields to start. And then I'm going to give this sections. Let's give that an empty array. I believe that will get us passing. No. It will get us not erroring. We need to render the form. So if you recall, a card view controller has a header, body, footer. In the body, it's got sections. And in a section, is where every single other type of view controller is rendered. And in this case, we've done it once before. We're going to do it again. We're going to say form, and that's going to be this dot form vc dot render. Now, I expect this to pass, and once this passes, we will fix some of this typing. But we hit Control Space. Yeah, we're still watching view, so maybe we just go over here and we refresh. Cool. A form with cancel submit button, no fields. That's totally fine. Let's fix the typing though. So, well, and then let's refactor this constructor. So first thing I'm going to do, I'm going to start in the innermost place, and I'm going to refactor going out. That's just because that's how I want to do it this time. You could also start by here and then refactor going in and extract, extract, and extract. So I'm going to select build schema, Control-Shift-R, extract to constant module scope. I'm going to call it family values form schema. I tend to put schema in the name of the variable, but not the ID of the schema because it's the schema, and to put schema in the thing, it just gets a little redundant. Now that that's set, I am going to go here and extract this to VC. I'm going to extract this to form VC. I'm going to command period on that, go declare property, private, go form view controller, and this is a generic, and we're going to pass it the family, no, what did I call it? Family values form schema. That doesn't exist because it doesn't, wait, look what I did, values form schema. No, it's family values. And let's create the type from it. Type family values form schema equals type of family values form schema. Now we've got it typed. Now the form, so, well, we don't have any fields yet, so it's not going to work. But now we got all the typing, so that's going to come in really handy later. And the constructor is nice and clean, the way I like it. Just creates a form, renders a card. Let's go drop in some fields. So if I jump over here, we're going to render a family name, family values. Easy, easy. So let's go test. Static async, form renders expected fields. So I like to kind of create my tests in this way, is like using something informative but not too precise, like expected fields, because rather than form renders name and value fields. And that's just because when we change the test and we want to render new fields, I don't have to actually change the name of the test, and I'm totally fine, and this is just a preference for me, I'm totally fine going form renders expected fields. Pass, good. Fail, oh, well, now let me go see what those expected fields actually are. So I'm okay not knowing what fields we expect when I'm looking at it at the test and the test file level. I tend to only really care if it fails, or, you know, while I'm writing it. So let's do form assert, form renders fields, plural, this dot vc dot get form vc, and the fields we want, let's say name and values. I'm just arbitrarily going to not put the word family in front of those. So family name, family values. I'm just calling name values. As expected, I get the get form vc is not a function. Now, because I've already set up the spy here, my test double, and I'm already all properly typed, I should be able to click here, hit command period, and go declare method and get that dropped right in. It's really going to try to help me by doing all that typing. It's not helpful. I'm going to delete it. I'm going to go return this dot form vc. I expect this to fail for a good reason, which is, I mean, they're all good reasons as we build our way there. Form does not render field name. Make sure it's in your schema. Okay, fine. But I just want to fix this type. So the type, it's mad at us because form VC is private. So I'm going to click. I'm going to make it protected. So I option delete deletes a line. Command delete deletes an entire row or everything to the left. And Command Shift K deletes the whole line and moves all lines up. Little fun little shortcut cram session there. So form does not render a field name. Make sure it's in the schema. So let's add it to this here first. Let's go name type is text. is required. Yeah, it should be required. And then let's do value type is also text and is required is also true. No, this is my awful syntax. It's going to save that. It's going to fix that. Now let's go into sections. I should have a fields. And then let me go here and look at that. Name, values. It's all beautifully typed. Does that work? Yeah, okay, we're still watching. I should just be able to technically refresh and see two fields there, right? Yeah, though it looks really bad for two reasons. One, we don't have labels, and two, that value should be a text area. So let's make it a text area. So let's start by updating the labels. In this case, I'm going to choose to put the labels in the schema itself because I'm imagining if we use the schema somewhere else, might be helpful to have the label. I could also put it in here, which we'll do for rendering as a text area, because you cannot define or declare the field or define how a field renders in the schema. It's only the structure and the form, ways we're validating. So name, kind of put label right here. It's arbitrary, however you want. Family name. And let's go label. Let's go family values. Okay, so that should have dropped in. Let those tests run. There's absolutely, positively no reason that a test fails for changing a label. I mean, okay. Someone might have a reason for wanting to do that. I don't. All right, family name, family values. Both of those are starred to indicate their requiredness. But we want to render as a text area. I'm going to write the assertion for this. This is kind of presentation-y, so you don't have to. I'm just for the sake of this demonstration, I want to do it. So protected static async values field renders as text area. Form assert. Form field renders as this.vc.get form vc field name values expected. Do this password. Signature? No. Tags? No. Text area. Cool. While that's running and it is failing, so I was going to jump out ahead. Let's make this pass. All right, so see how values here? I'm going to wrap that as an object, turn that into an object, and hit name. So that's going to leave everything as it was. Now I can override things, right? The hint, the label, placeholders, hints, buttons. I can even specify our own view controller. In this case, render as. There we go. Cool. While that's running, because I expect it to pass, sweet. Smartwatch is going to now run all tests. I'm sure you picked that up already. I'm going to do some extractions here to keep this thing from getting dotty. Too many dots. So we'll call this form C. Change it to this. Now, I don't want it to even be a function, honestly. From my perspective, when I'm doing these tests, I'm fine treating it as a property and not knowing the difference. Doesn't assist. Oops. I'm not. Should I do this one? Should we do this one? Yeah, let's do it. Control Shift R. C. Let's get rid of the function call. Let's change it to this. Get to override the getter. Cut it. Down there. Wait, let's look. Let's look. Refresh. Sweet. Okay. So we got our form. We've got our form fields. Validation's done for us. So we just, because we set those fields as required, it's going to look just fine for us. The next step now is to make it, when we actually fill it out, we hit go, submits it. You know, and I guess also we can make the cancel button redirect back to root. You know what? Let's do that before we hit the next check there. Let's make cancel, redirect back to the root skill view. So now we at least got like a loop here that's closed. So let's go test, objective, static, async, clicking, cancel, redirects to root. We'll do await, EC, assert, action redirects. I believe we just did this. And what is the action? The action is we'll go form interactor, right? Or is it just interactor? There it is. Dot cancel form. This dot form VC. And then the destination ID is 8-bit stories.root. And then the last thing we need here is the router, which is this dot views dot get router. Just get it off the view fixture. That needs to be a function. There. So check it out. Clicking cancel redirects to root. The action is using the interactor to cancel the form. It's using the interactor to cancel the form, set the destination, and the router. So let's test this out. Oh, no, let's go make it pass. We go views, skill controller, views, as values, SVC. So to our form, let's go on cancel. This dot handle cancel form dot bind. All right, we got handle cancel form. Let's go ahead and implement the first version of that. It's private async handle cancel form. That's going to at least fix that error. You don't have a cancel handler. Try on cancel. We did that. Oh, I spelled that wrong. It's going to be extra mad at us about that. Just should be. What am I doing wrong here? Handle cancel form. Got the L. Well, you know, I think this is where I say that's why we write tests, is I misspelled that thing twice. Now look, I expected you to be redirected, but was not. All right, now we actually need to do the redirect. But if you recall, we can't just do that because we don't have a router. We don't have a router because we haven't loaded our skill view to put it in a state where it can receive the router. So let's go and let's knock that out. I'm going to move pretty quick on this one because we've done it before. We actually just did it. So we're just going to do it again. Value skill view. I'm going to say await this dot views dot load. Pass it this dot VC. Then from here, I'm going to go async load options, skill view load options. I'm going to destructure the router out. I go this dot router equals router. Then inside of here, I'm going to say await this dot router dot redirect 8-bit stories dot root. Then I'm going to declare it. So I'm actually kind of thinking this should pass, right? Yeah, look at that. So while I'm finishing the typing and declaring the properties and everything like that, we are passing. Sweet. All right, let's jump back over. I'm going to hit refresh. Now I should be able to hit cancel and go back in family values and go forward and cancel and values and cancel. And we have a full loop. Now no one can get trapped. Sweet. Okay, I think it's time to start emitting an event. Let's make submitting the family values form actually emit the save family values event. Then we'll get on to persisting. One thing at a time. Go test, protected, whoops, protected, static async, submitting form emits save event. This dot event faker dot fake. Whoops, I got too many parens in there. Dot fake save family values. So I'm just going to start there. That's going to be mad at me because that method does not exist on the event faker. So command period, declare method, command click. public async. Here, await event faker dot on 8-bit stories. Instead of submit feedback, I'm gonna call it save family values. What should it return? I think it should return your family, which is name. I'm just gonna make it random. Generate ID and values. Generate ID. I'm just kind of making this up. We have not defined any of this. Which makes me think, should we call it save family values or just save family? Let's call it save family. And then let me F2 on this thing and do a save family. Yeah, the family's got a name and values. Cool. And it's saving that. All right, sweet. So now let's go. Oh, wait. This dot load. I didn't make that yet. I guess I'm going to do that. I'm going to do this. We're just going to extract this. Method. Load. This. Let's put it down. Now let's fill out the form. Let's go await this dot form vc dot set values. Yeah. There we go. Look, name and values. Let's do generate ID. Values. Let's generate ID. Okay. So now we've set the values. Now let's submit. Wait. This dot. No. Await interactor. Dot. Oops. Interactor. Dot. Submit form. This dot form VC. All right. So I missed one piece of this. So this is actually not going to fail because I need an assertion. And the way that we test events is by first testing, were they emitted? And we're going to leverage, so we're getting this type error here, syntax error, which we should not be getting. Wow. Let's see, what did I do? I broke the event faker, so we can click on that. I accidentally hit return there, I guess. And fake, save, family. Okay. So if you see here, the way that we test an event is multi-stages, because first we just want to make sure it's emitted, then we want to do some assertions against the target payload, depending on the signature of our event. In this case, though, all I really want to do here is I want to make sure that our event is emitted. So I'm going to write the code here the way I wish it worked. Hit true. That means I need it was hit false. And then down here, I need to go assert.isTrue was hit. You didn't emit the save event. Okay, so check this out. I did not actually define this in a way that would call that. So let's do that real quick. So I'm going to make an optional callback. It's not just going to be a function. It's not going to accept anything or it's not going to return anything. And then inside of here, I'm going to go CB. I'm going to optionally call it. Now, as you see we've done in these other listeners, is when our listener gets called, it calls the callback. And in our case, all we're doing is just making sure that that was hit is true. Looks like this has not been imported. So we're going to get a assert is undefined. Assert is not defined. Perfect. Let's import the one from test utils. Go. Oops. Now we're going to get the error that I expect, which is false is not equal true. You didn't emit the save event. False is not equal true. Okay, well, let's go emit it then. Let's go values, skill view. Let's add an on submit. Cancel. Let's go on submit. This dot handle submit. Fine. this. Okay. Private async handle submit. Wait. No. Const client equals await this dot connect API. Await client dot emit and flatten. And we're gonna do the save family. Cool. We're just gonna start there. The event doesn't exist. We haven't defined any of it yet. All totally fine, because the errors are going to walk us through. The event signature sort of, oh no, you either need to create the event using Spruce create event or do some other things that are possible options. In this case, we just want to go create dot event. Readable name, save family. The event name in kebab case is save dash family. The camel case version is save family. We want to use our existing version. We don't want to give new versions. That is going to, let's get back to our test. I expect this to fail for a different reason. Something more along the lines of invalid payload, invalid target, probably some version of that type of invalid signature, or the more accurately, the form of the data you're passing does not conform to the schemas that define it. Let's see. Response payload. Family does not exist in response. Well, that's cool. Nothing really exists how I want it yet. So let's go to the emit payload. Inside the emit payload, let's go family. And inside the family, I'm going to set its type to schema. I'm going to say is required true. And then the fields, I'm going to go, watch this, name, text is required. Required. Why is it doing that? Required true. And I'm going to change this one to values. Oh, wait. It's not fields. Well, do you know what? Let's just pause this for a sec. So let's just pause this for a sec. Take a look at this. If we go into the values skill view controller, we have the family values form, which is name and values. I was just about ready to define name and values again. So it's like we got this schema kind of taking shape, like this form that is emerging that is a family, and a family has name and values. So here's what I'm going to do. Instead of having this defined everywhere, I'm going to go control space, and we're going to create a schema that we're going to be able to share between all these places. And we're just going to call it a family. So I'm going to go create.schema. And its readable name is family. Its camel case name is family. I'm going to choose that version. And now it's writing the builder. The builder is what the CLI uses to generate the fully typed schema that we're going to use in our code. But for now, let's do this. Go into schemas. We have family builder. And I'm okay with type errors and things happening now. All right, look at this. So we have a name. Its type is text. It's required. It's true. Let's call it. Let's go label. Say family name. And let's go values. And let's go text label family values. Both these fields are required. Okay. So inside of the form, I want to use this built schema, the full schema. So I'm going to go to values SVZ. Instead of family values form schema, I'm going to go family schema. Actually, you know what? I think we got to sync it first. So now that I've defined this here, I'm going to hit control space. We're going to sync schemas. Right. See that we got that error because I've got that type in there. Let's see, family schema, not yet. So let's go fix this type then. Let's go into our emit payload. Let's go. Its type is schema. We're going to go to options, and we're going to set the schema here. Okay, because we're in an event or sorry, because we're in a builder, we're going to reference the family builder. This is different than the family schema, which is the built schema, fully typed based off the builder. So the reason is if we in here were to type family schema, which has not been generated yet because we keep having these type issues. Well, you can't have a builder depend on something that's already built. And you end up in this position where family schema actually doesn't exist yet because we've not been able to generate schemas because I had this type issue in this. So I'm going to go family builder. So I'm going to talk through this a little bit more so you get the feel for it. So watch this. So let's do that. Let's go. The emit payload is a family. Watch this though. I'm going to copy. I'm going to go target and get rid of the target. We actually don't have a target. We're going to make this event global. We're going to make the response also a family. So now we're not having to define the family over and over and over again. We're just going to have one family schema. Now, if you recall in here, we have a place for permissions. Let's go look at how we did the permissions in submit feedback. And let's just copy that. Can submit feedback. Okay, well, okay, I don't want to copy that exactly. Let's go and import this. I had to like delete the E and retype it. And instead of can submit, I don't like that. Let's go to 8.permissions. Let's copy this permission. And it's what? Can manage family. And we'll just say that that's values and members and everything. So we don't have to create permissions for every single thing. We just have can manage family. Can manage family. And what we can do, I believe, is give me the autocomplete. We can go description. There it was. Say, can this person manage their family, name, values, members, etc. Again, I'm just going to create this one tied to a logged in person. I'm just going to do this one because I don't want to have to go create a can save family, can load family, can add members, can update values, can update names. It's just, can they manage a family? And right now, anybody who's logged in can. So because I updated the permission contract, I'm going to go sync.permissions. So I got permissions. Now I'm going to go up a level to the event options here. Let's go save family event options. And we're going to go can manage family. Perfect. So now I think I have all the event signatures and schema builders and everything, right? So now let's run sync events. Just as a recap, if we go to the emit payload, you will emit it with a family pointed to the family builder. We're not going to have a target. We're going to make it global. So that means it's not scoped to a location or an organization. It's just a globally available skill. And we're going to respond with a family. Now remember, because we're in a dot builder, these are untyped. They're the source from which the actual schemas are generated. So that worked. We had no errors. Now watch this. Now we can do what I wanted to show you earlier. Instead of, look at, same thing, name, values. It's the same thing. Don't want to have this defined in 10 places. I just want to use the family schema. So watch, family schema. Now that it generated, now I'm not using family builder because builders are for when you're building the types in our production code. So none of the builders are actually, you could even really not consider those production code. They're the source files that are used to generate the production code. The schema is the actual production code. And you see it's here, Spruce 8-bit stories. So I can command click on this. Here's the typed schema. I can command click on family schema. And right above it in this schema.types file that gets generated. So if I go into here, it's inside of source.spruce schemas schema.type. So here's the 8-bit story schemas or the Heartwood schemas. Any skill that you depend on, it will download their schemas. That will make testing against their events, so easy. let's say we depended on another skill altogether, writing the event faker and emitting, I mean, it's the same process, whether you're doing the event or one of your dependencies are, with full validation, everything. Okay, let's get back on track here. In schema.types, it's got all your typing, and you can see here's a family. It's got a name, the family name, and values. So one more thing, we're going to get rid of this because we're not going to use it anymore. This is going to get mad at us about types. Let me get rid of the build schema. See, that's fair. This type doesn't exist anymore. But though this type doesn't exist, the type that was generated from that builder, the actual schema type, does exist. So how do you access that? Well, we go spruce schemas, enter to import it, dot, and then our namespace, 8-bit stories, dot, then our version. I struggle to say that word for some reason. Dot, look at family. No, family schema. The form doesn't want the built type. The form wants the schema. And because it uses other elements of it for our typing. Now, did we create a .types file? We did not. Let's do that real quick. Do you see how we've got this full namespaced type here? I don't know if I care for that. I'm going to Command Shift E to bring this in, and I'm going to create a new file called 8-bit stories.types.ts. Command / to split the screen, and then I'm going to take this. Watch this. Export type family schema equals, and then while I'm in here, I'm going to go export type family because I know I'm going to need that. This is mad because we haven't imported that. Now, spruce schemas can be imported from any one of these modules. It uses declaration merging to make it available everywhere. There's family schema. So I deleted all the namespace and went right to the type. I'm going to Command period to import it from our types. That's going to allow me to delete the spruce schemas import here. Now, see, if I'd done this type aliasing and typing before, when we switched, I probably wouldn't have had to go and refactor this file at all. But now it's done and this typing is pulled out. We are good to go. So where are we on our tests? Let's reload. Okay, so where are we on our tests? Jesus, this is... All right, where are we? Looks like we have an error. What is it? Payload is required. Save, family, emit, target, and payload. Payload is required. That makes sense though, right? So if we go to values.svc and we go to handle submit, I'm not passing anything. So we're going emit and flatten responses. We're emitting the event, but we're not passing it anything else. Let's go payload. Yeah, that's all it said. Payload's required. So let's just send it payload then. It's definitely mad at us. That makes a lot of sense. Family is required. Okay, family. Still mad at us. Family.name is required. Family.values is required. Let's go do that. Name. Oops. Values. Well, that should solve that, right? Sweet. Obviously, that's not the right value. So let's go write that last test to make sure we're actually passing the values we want. So how do we do that? First thing I'm going to do is see how we're calling set values and passing name and values. Well, I want to do a comparison that this is being passed the expected stuff, the expected values. So the first thing I'm going to do is I'm going to extract this out of here because I actually want these. I'm going to say expected. Okay. And then I want to make sure that I'm checking the payload that was passed to the event, and I'm going to use our faker. But we have not set up that support. So you see in these ones, we're passing target and payload around so we can get access to it from our callback. I'm going to do the same thing. Just select these things and go to target and payload. And then I'm going to type this one in Spruce schemas dot 8-bit dot version dot save family target and payload. Let's extract it. Save family target payload. That out there, I think. Okay, so now we're putting in our faker. It's receiving the target and payload. We're just passing it right to our callback. So I should be able to go into here now, and I'm going to destructure payload out. Then I'm going to go past payload. It's payload. And now see I'm working my way up. Just to make sure everything that I need is declared. Let past payload equals save family target and payload. It is going to be the payload or undefined. Then I should be able to just go assert dot is equal deep ask payload expected. Right? Why is that map? Family is missing. Okay. Because I want to go dot family. That makes sense, right? Well, look at that. A does not equal the randomly generated ID that I passed. Well, let's make those match. So with values, .svc, let's get the values off the form. So let's go with name values equals this dot form vc dot get values. And let's go name values. So let me hover over these, see how string null or undefined. A form itself doesn't actually know if the things are filled out or not when I'm calling get values. So while onSubmit can never be called when the form is invalid, our code, you can call get values on a form whether the fields are filled out or not. So that's why when we go name, we're not actually getting the name, we're getting name null or undefined. So what I'm going to do is I'm going to go bang after each of these, and that's going to remove the falsy, the undefined and null, and cast them as string. There it is. So now we have submitting, saving the family. Okay, I think next up we should gracefully handle an error. So before actually having this render an alert if it fails, let's go and let's test and just see what the UX is, and then learn a little bit about how to debug while we're here. I'm watching views, so all the changes I'm making are being is bundling and registering the skill views with Heartwood, so I can refresh. It's going to get the latest of the skill view source. I should be able to say my family are Romeros, or the Romeros, and maybe I'll add a little bang to it. Values go here. I have some. I'll drop those in later. I hit go. Nothing happens. So how do we start? Where do we look to start debugging? Pretty easy. Developer down to toggle. Command Option I for inspector. Toggle inspector is Command Option I. And look at this. Uncaught promise. Oh no. No skill is listening to 8-bit stories.save family. I've let the proper humans know. Now, in a production environment, we would set up a log transport to have these logs sent to Slack or email or whatever we want. I actually really like and am a proponent of logs being sent real time to you, and because this usually 99% of the time when something's being logged as an error, it's actually very important. And it's we do not develop via logs, as you can tell, so there's very rarely are logs being written because it's actually just not helpful. So you know what? Before actually writing the test to render the alert if the save fails. Let's just clean up this a little bit. So we have the submitting form emit save event. I'm going to remove the was hit, because if you think about it, this deep equal, it is actually also checking if the event was emitted. So we don't need the was hit check in addition to it. So let's just get rid of it. I know I've said it before, but it's another example of you cannot look at the tests and know how the code was built. Is some of these stair-stepper tests and stair-stepper assertions just end up getting cleaned up in the end. Well, okay, we are now ready to render an alert if emitting an event saves. There is a good case to be made. We should have done the render alert before the actual successful save, but we didn't this time. We've got other events in the future. We'll do those in a little bit of different order. You know, I'm going to talk about it a bunch, but it kind of fits into that concept of discipline versus dogma. And I thought a little bit about it, and I think the difference is discipline you can defend. Dogma is just because. I don't know, it sounds obvious, but that's also why in some cases I will ignore type errors. There's the discipline of types that makes them useful, and then there's the dogma, which is make them all pass all no matter what. And sometimes that's not valuable. Okay, I'm talking too much. Let's get started. Protected static async save event throws renders alert. Nice. First thing I'm going to do is make the save event throw. So I'm going to go await event faker. I'm going to use the one from test fixtures. Again, you can go into your event faker and create a make throw event. I've never regretted just using the event faker tool directly to make an event throw. I mean, I'm not even paying attention. So if you wanted, though, it might make sense that you go into the event faker that we've been building and create a method called make save family throw, and I could just call that. But you know, I've never regretted doing it this way. And if I ever am in a situation where this causes me pain and it makes sense to put this one thing into an event faker or extract it away in some way, I'll do it from then on, and I'll share the lesson. For now, though, we're going to save family, and we're just going to make it throw. This optionally accepts an error. I don't care. I don't care the type of error. So first thing we need to do is we need to fill out the form. And if you see right above here, we've get the form view controller and we set the values on it, and we're just generating random name and values. I am going to select both of these into a method. I'm going to call it fill out form. That's pretty clean, right? And then it will return, go option down arrow. It will return the values it used, which are randomly generated. So step two, step one is making the event throw. Step two is going to be filling out the form. Step three is going to be submitting the form. Look at this. We actually do it right here. Now I will use my heuristic of every dot in a line of code exponentially increases refactor pain. And here's submit form and a form VC. So I'm going to kind of use that rule, again, that heuristic to guide me in knowing what I'm going to extract, and then kind of applying it here. It's only one dot. So even if I were to extract this to somewhere else, it doesn't cut down on the refactor pain. And it's also not used repeatedly. So it really is tough to make the case that this needs to be extracted into something. It's only used once and there's only one dot, where this is two dots. So if we ever wanted to change what effectively the action was to take that causes this event to be emitted, so no longer it's tied to a form submission, it's tied to something else. I don't have a good example, but in the thought experiment, if we ever wanted to have this thing submit in anything other than the form submission, so have it emit the event in something outside of the form submission, we would have to go and change what interaction is causing it. If we ever changed and moved away from a form to something else that was actually responsible, we'd have to change it here. So this has got quite a bit of refactor pain, and multiply that with how many times you use it, if I were to just, let's say, copy paste it here, you don't have to trust me on this one. Just don't listen. And then one refactor is all it takes to go, never doing that again. I'm just going to extract that into a submit. So, let me move this down. In the test code, I always like to put the supporting methods at the bottom. In production code, I just leave them where they are because it ends up making the code very readable, and it actually gives it a really nice natural order where you're going down and you're hitting things in the order that they actually happen. Okay, so now we need to assert that an alert is rendered. We're going to go await VC assert renders alert. And the first thing it needs is a view controller. That's going to be this.vc, which should be a reference of our values skill view, and an action, which is this. That's our callback that when invoked renders an alert. Expected await this.alert to be called in your da-da-da-da-da. It wasn't. I was interrupted by this error. A faked response to blah, 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 blah through an error. If this failed the test, it's time to try catch and possibly render an alert. If it was expected, the test pass, you can ignore it. There are some cases where alerts will fake some things, alerts will happen, and we'll just log it and move on. But which is kind of calling out this second part. If this was expected, the tests are passing, ignore it. All right, let's go into the values skill view controller. Let's go to, is there a handle submit? That's one nice thing about this kind of nomenclature is any callback I preface with the verb handle, and it just makes it really easy to know what is responding to what. All right, this is the part that is going to get mad at us. I'm going to type it as any because I'm not dogmatic about my types. And also, I've never, ever regretted it. It's never bit me. And I put it in the catch like an idiot. Let's go back to try. I am going to go this.log.error, saving family failed, and gonna just pass it the error. There. So that's going to fix the interrupted by error. But now it's just saying, we didn't render an alert, so let's render an alert. And the way I'm going to do that is I'm going to go this.alert. And we got a few things, a message, a style. What styles do we have? Yeah, error, info, success. We are not concerned with that. We saw earlier if our style is success, it's effectively ignored in the tests. The same thing with info, but it defaults to an error alert, and those will hard fail your tests. So you're never accidentally having something go wrong in your try catch. But I'm talking enough. Let's go to message. I'm going to do this error.message or failed to save family. That's almost never going to happen. I guess a quick call out. It is our convention in this platform to, when you are referencing a variable or naming a variable that is an error of type error, any type of error, we don't give it E, we give it because E is actually what we would use for an event, because events are actually better than errors. So they get the cool name, they get the short name. So that should work. We should get an alert now. So I'm gonna click over here. I'm gonna go refresh. I'm gonna say mirror values. Go. Yeah. Oh no, no skills listening. Okay, now admittedly, that's an ugly error. We could put in our own message if we wanted. This error probably has a code associated with it. Up to you if you want to get fancy. I would not. If you wanted to actually use or actually render an error message that's less technical, doesn't have the event name in it, don't write the test for that. Just like go in and change the language. Okay, but that being said, though, this should have logged as an error. So let's jump over and look. Is it Command Option I? Look at that. And then if you see here, we've got saving family failed, options, code, skill, not listening. So what you could actually do is you could go err.options.code and make sure you do your null checks, your question marks, to in case some other type of error occurs, which is, I don't know if that's ever happened. And you could check if the code is skill not listening and change the error message to say, oh, I don't know, part of my system is down. My bad. But I don't want to do that. I don't know. This so rarely ever happens that it's never really caused me too much pain. Or any, really. Anyway, okay. We've got an alert. Sweet. What is next? Let's jump over to, well, I guess before what's next, is there any refactoring we need to do? Let's jump to the value skill view test. I mean, this is pretty clean, right? We make an event throw, we fill out the form, we assert an alert, and call submit. I guess one thing maybe that I like, so if I hit go, I really, and you can see it logging that error, I really, let's use busy. Let's do busy. So this is a little progress indicator. I'm not going to test against it, but there are assertions around card is busy, assert card is busy, set is busy true. I am not going to do that because to me, this is just presentation, and I don't like testing things that are specifically presentation. Again, the dogma side of that would be never test presentation. The discipline side would be do it when you can defend it. And there are some places where I can defend testing presentation only. Busy, there are times where we have some more complex logic, and the busy does have to, it's just more than a like true to false, wrapping some operations. And if it gets more complicated like that, then it does make sense to assert that a card is busy or not. All right, so let's refresh. So again, I have run watch.views. Let's do family values. Go. Well, we can't see the busy. Yeah, oh yeah, there it was, right? Just errors so fast, so you don't get to enjoy it. You know what? Let's test this. Let's test this. We go form VC set is busy. Form VC set is busy. So instead of it setting the busy state or updating the state and setting busy to true on the card, it'll do it on the form. So see how that looks. Again, not writing a test, all presentation, and no good case, I think. Yeah, okay, I like that better. I like making the form busy because it actually does it just over the submit controls. And that is satisfying, right? Cool. All right, that is rendering an alert. I think next up, we actually got to create the listener. Okay, let's do this. I think it probably makes sense, or is time to start another test. So look over here, we have values, we have value skill view. Let's do, this might have been better named family versus values, but let's just keep going. I'm gonna go and add a new folder in the behavior directory. I'm gonna call it family. No, did I say revealing finder? That's to do. Right click, new folder, family. Yeah, now that I think about it, I think we need to rename the value skill view to the family skill view. Let's do that after we get the listener working. Okay. So now I've got that directory created. I'm gonna hit control space. Oh, I've got my watcher going. I hit control space again and hit restart. Create.test. Behavioral, save, family, listener. Camel case version of that looks good. It's gonna go in the family behaviors. And we're gonna pull from the abstract 8-bit test so we get any helpful stuff that we created. Should be able to come in and click on that, right on, trash that, jump back to here, and we have our first failing test. So this is us doing our save family listener. So let's just see if we're listening. So I'm gonna say skill is listening. I'm gonna boot this skill. Whoops. Sweet. Let's get rid of this other test. Let's cut that out. And then let's emit the event. Why am I hitting space at a dumb time there? Faked client, emit and flatten. 8-bit story, save family. I'm just gonna save it, and I'm expecting it to yell at me because I did not pass it the right target payload right. 8-bit storage family has been handled locally. You have two options. Oh, make sure you're listening or use a faker. Let's just make sure we're listening then. So control space, create. Oh, before we do that. No, let's just do it. Create dot listener. We're going to rearrange later. And let's go 8-bit stories and say family. Now I expect the error to change from no one is listening to listener not implemented, I think is what it's going to say. And obviously this is mad at us because we have not supplied it the proper target and payload. We will in a second once it yells at us about it. But let's just type the minimum that we need to get the next error, and then let's let the errors guide us. I'm going to jump back to test reporter. Sweet. It actually didn't do listener not implemented. It didn't even emit the event because our payload is wrong. It says payload is required. Cool. Payload, let that autocomplete do its thing. That IntelliSense, and it's mad too. Let's go family. Inside of family, I bet we have name. I'm just gonna do random. I'm a big fan of random strings. Lots of random numbers. Look at that, listener not implemented. And if we see that first line is actually happening right here, I can command click on it, and there we are. And you see the code. Now this is TS ignored here because we actually don't have a listener not implemented error configured locally. Doesn't matter. It's just helpful to see it here, and we just delete it. It's gone. The response payload to say family is invalid. It needs a family property. So let's go family. Close that, and there's a name. And now I'm in production code, so I'm not going to generate an ID. Yeah, I'm just going to fill it in with junk. I'm on a Dvorak keyboard, by the way, this is ASDF in Dvorak. It's just vowels. All right, cool. Now, what do we want to do? I think we're going to get into data stores. Let's make sure that when you save a family record gets written, because we're going to persist. We got to persist the family, right? Let's do that. Test, protected, static, async. Saving family creates family record. Sweet. This is cool. Okay. So the first thing I would do in this is go await this .boot skill because I need the skill booted for each test. I'm just going to get out ahead on this, and I'm going to go implement the before each right now. That is just going to save me, coming back to discipline versus dogma. The dogma would say first write it, then refactor. But that's just too much work. I can just refactor it now, and then I just know this step. Let's select the emit and control shift R and say what? Extract method in class, and we'll call it emit save family. Change that reference. Cool. Okay. Save creates a family record. So let's do this. Await this dot emit save family. And now we need to check to see if it saved a record. But how do we do that? Introducing data stores. So data stores is a layer of abstraction over databases, and it really only provides CRUD ability. And right now we support Mongo and Postgres. I'm sure that will change maybe by the time you're watching this. And it is not an ORM. I am not a fan of ORMs. In fact, I have only memories of regretting them. And so we do have raw query support. Easy enough. That being said, though, let's use the data store layer to actually find that a family was persisted. So this is 2 steps right here. So the first step is getting the family's data store, because it's on the object that comes back from it, the data store object. We have methods like create one, find one. All the usual CRUD operations. So we'll go const families equals await this dot stores dot get store We're going to call it families. I couldn't find a store named Families. There are actually no stores available. If you are testing, you may need to run spruce.create store to fix this. Look at that. As you can see here, I also didn't put store in the name of the variable. Actually, what the object is less useful than what it is wrapping or representing or what it's giving us access to. So I don't call it like store or family store. I just call it families. And what you'll see when we start to do some refactoring and things down the road, we might actually not use a data store. We might create an object that sits above the data store that, I don't know. I'm not going to try to come up with an example. It's going to be a bad one. But the point is, we might actually swap out a data store for another type of object that is working with the data store directly. And if you have the word store in the variable name everywhere, it becomes misleading. It's easy enough with IntelliSense that I can see like, oh, this is called families, so it gives me access to families, and then the type doesn't work. It's typed never because the typing hasn't been built for a data store yet called families. So let's do that. Control space, create.store. The singular name, family. The plural name, families. Pascal case name, Pascal of the name, family. That looks good. Here we go. Installing the store feature. Now I actually expect this family to, this test should kind of stop erroring actually once this is done setting up and installing. Sweet. Okay, that's done. I'm going to jump back to our test watcher. Oh, what in the world? Let me do Command Shift P, task, run task, or run test task. Yeah, right there. Yeah, I don't know why I did that. I tried to run the test while it was still running yarn. Sweet, look at that, no errors. Okay, let's get into configuring our data store because I think it's self-explanatory. Let's get in and start setting it up. So I'm going to go back to the root and go to stores. This is the new families store that was generated. And as you can see down here, this extends an abstract store. There's a lot of typing, but so you can ignore the typing. I just want to show you some of the method names. There are hooks like will create, did update, will scramble. So we have this concept of scrambling where if you need to kind of remove someone's record, like a person record, but you still need that record to exist for referencing in relationships and places, you can set up you can actually scramble the record and remove all identifying information, but keep the record in there with its ID so all the relationships still work. This has got a lot of stuff in it that are helpful. Delete one, find, count, all the usual suspects when it comes to interfacing with the database. But look at this. Inside of a data store, there are a few schemas that are relevant. There's the full schema. This is the data that we want and the structure of the data we want sent or to receive on a find operation or a find one or find many or whatever it is. There's the create schema, which by default takes the full schema and drops the ID field. This is the schema that's used to validate data when we're running a create operation. Then there's an update schema, which drops the ID field and makes all fields optional. This is for when we want to perform an update operation. This is the schema that we use to validate that. And database schema, this is what it'll look like in the database, the actual database record. And so what's really cool is if you're in an organization that has a lot of opinionated database experts, you can actually model their database in the database schema, keep your schema in a form that's way more useful for you, and then map those using a plugin that we have that we're actually just not going to get into here, but you can check the documentation. And so what you get to do is not have the disciplines or the dogma of the database team affect your code. And this store layer is just going to guard you from that. And I tell you what, worked with some companies that really care about I have a lot of opinions about the naming of columns in a database, and I did not want that pass through. Okay, enough talking. Full family. What should we put in these fields? Well, if I recall, we actually, do we have a schema? So if I go source, schemas, family. So family builder's actually not a .builder file. It's not production code. It's effectively a configuration file. So it's the thing that is used to build the schema. And the schema is the production code. So what that means, though, is we should have a family schema object available. So I go family schema. There it is. Now the family's store expects you to pass data that conforms to the family schema. When we go to create one, it'll take the fields but drop the ID field. Do you know what? Do we even have an ID field? We don't. Name and values. I think it probably makes sense. We go into the family builder and give it an ID field. Type ID. I think the ID field's like a good example of a field that a database admin might have strong feelings about, and maybe they want to call it family ID or something like that. So now that that ID is included in our schema, I'm going to run sync events. So sync events is going to sync schemas and then all the events, and anywhere we have the family schema referenced in any of our event builder files, that's just going to get updated also. So let's just do that. I expect once this is done, this little warning is going to go away. There it is. It goes. Sweet. See, our schema types and our event contracts are updated. Perfect. Well, look at that. Save family emit target payload. Family is required. Well, I don't want that. So if we go to save family emit payload builder, so I just type sav fill build, go to the payload, it's referencing the family builder, but we don't want that. We want that. We don't want that. So let's do this. Let's change this. Whoops. Instead of just referencing the family, let's go build schema. Let's give it an ID of create family. And then let's go fields. And do let's unroll, pick, no. Drop fields, family builder. So builders reference builders. Do not reference a built schema production code in a builder. You create this kind of space-time continuum paradox where the builder, the configuration files are dependent on files generated from configurations, and it's gonna be a bad time. So let's just drop ID. Oh, dot fields. Yeah, look at that. So now we have a create family that is a family without an ID. So if we ever change the family schema and add new fields, not only will the data store now use that new schema, but the events will also. And so this makes changing the structure of your data, I would say possible, because I could change the structure of the family schema and everything will quote unquote just work, or I'll know exactly what's wrong. Is it a listener? Also, check this out. We got value SVC inside. See, it's mad at us because we don't have an ID field. But if we check our form is using the family schema too. Now we are only explicitly showing the name in the values field. But again, the form references this. Let's think of that built schema as the source of truth. Our form renders it, so our visualization layer. Our event references it, so our communication layer. Our data stores references it, so our persistency layer. And so, as you can see, using this one source of truth for the full stack, it makes life a lot easier. I'm telling you. Sync.events. Let's let that finish. Okay, so now we've got 19. Now we got 6 problems. The response. save family.listener. The response now needs an ID, right? Because we'll respond with the family's ID. We don't have to. We could not respond and just respond with name and values, but I don't know. It's kind of just like normal convention when you're getting a record back from a database, you get its ID with it, right? Okay, so we still have 5 problems. Let's just go clean this up. It makes me feel like I'm failing. So Command K P, search not being used, fine. Command K P, families is not being used. Well, you know what? Let's do this. Let's make this test properly fail, and I wonder if removing that's gonna where that's gonna leave us. So we're gonna go const total equals await families dot count. I'm not gonna pass it a query. I literally just want to see if there's a record written. Assert dot is equal assert. Oh, now I need assert, right? Make sure you get the one from test utils. None of these other asserts. I mean, you could use them if you wanted, but as you might imagine, the test util in this assertion library has a lot of tests against it. So you can definitely depend on it. It's equal total did not write a family record. Oh, GC 1. And we have 1 error left. Let's go. Command KP. In our save family faker, we don't have the ID. So as you'd imagine, watch this. I double click on that and hit save family. Okay, we're only calling it one place right now, but you can see how changing this event signature is now could potentially cause a cascade of changes. So by having extracted our faked listener into the event faker class, we're only going to make the change once, and I'm just going to generate ID. Cool. And I think we're warning free, not error free. Our tests are telling us we're not error free. Did not write family record. Let's go write a record in the family store. So make Command P, right, and go save family.listener. Now, you see this event, the spruce event? It's got a lot of helpful stuff in it. So if I go event dot, it's got a database object. So that the database object sits beneath the store, and it just is very raw and pass through. Whereas our store has introduces the data validation and the hooks and everything like that. And so I just want to use the store. I don't want to use the database directly. So go see there's dot stores. Well, I'm going to be a little dogmatic here. I'm going to destructure it. And I think this is just the convention. So it's just, if you kind of take the path of most expected, which is really nice if we're collaborating on code, destructuring stores like this is the way to go. So let's get our families store. Families was await stores.get store. Families. Now let's write a record. Let's write a record. Await. Yeah, that's like, sorry, that's the best impression I'm going to do. Create one. Name. Values. We're done. I guess let me make sure we break anything else. I don't think we did. Cool. Okay. So let's do our next test, and let's make sure that the family record is written, the name and the values match. Right? Saves name and values. Cool. So how do we do this? Well, we're going to need to emit this again, but we're going to want whatever this is returned. Or we're going to want to know it. We can't just do that generation like that. But maybe we do this. Do we have an 8.types? Okay, watch this. Export type create family equals spruce schemas dot 8-bit dot that dot create family. Here's our create family type. And if I command click on it, what's that look like? name and values. And look at family name, family values, because that's just the label gets rendered right there. So let's do this. Partial, values, optional, partial, create family. And then let's just mix them in right afterwards like that, right? So I like doing it this way. That way I only am passing what I actually want to override and not having to pass the full family object. And now imagine if we did another family refactor and new fields were added. I don't want to have to go everywhere I'm calling emit, say family, and now add the new field that we've added. I'm just going to pass the ones I care about. So let's do this. Const name equals await this. No. What am I doing? Generate ID. Let's pass the name. So can you see here? I've got to get this the data store again. I don't want to have to get this .stores.get store again. I just want to have the data store available. And so there are two ways to do this, and there's kind of two ending points here. One where we put it in the before each of our current test, and one where we put it in the before each of our abstract 8-bit test. The benefit of putting it in the abstract 8-bit test is it makes that store available in all of our tests. And in general, it's not uncommon you need a data store in multiple tests. There is a risk that the abstract 8-bit test gets really messy and polluted, but that really, it doesn't happen too much. Okay, where were we? We saved the family. Now let's get the family store. So right now, I refuse to call this .store.get store again. I'm going to reference locally. So I'm going to command period, declare static property, private. Oh, nice. Cool types, bro. Just going to store. Yeah, look at that. Cool. Option up arrow this to the before each. I'm going to do it before the boot skill. This doesn't matter. Actually, it really doesn't matter. I'm going to put it up there because I think what I'm going to do after this all works is move it to the abstract 8-bit test. So it's going to happen before boot skill there anyway. Let's get the record. Const family equals await this dot families dot find one. This does require a query, so I'm going to pass an empty query. And I'm going to say assert dot is equal family dot name equals my new name. AEOU does not equal 4D99. Also, this deprecation warning looks like something lower level, so I'm going to investigate that and make sure that stops happening. Array.isArray, util.isArray API is deprecated. I'll have to find when that's happening and fix that lower level. Sweet. So save family listener that's not correct. So let's go save family dot listener. I went sapphire dot list. That fuzzy match is super nice. We need to pull the values out of the payload. So let's go payload. And let's destructure name out of the payload. And then let's just go name. No. I was wrong. It's family. And then out of the family is a name. I don't even want to know what that error is. I'm embarrassed I even did that bad, that poorly. Perfect. Now let's check values. Assert.is equal family. I don't even need the period, right? Because what's going to happen if I go here is it's going to add it for me equals values. Now, is values a string? It is. If it were an object, we'd have to do an is equal deep versus a strict equality check. We need a deep check. It needs to be deep. Does not equal equally difficult to pronounce string. Let's go into here. Let's destructure values. Values. Sweet. Okay. We can just tell right here what might be the next thing. Do you see what we're returning from this event, listener? So the convention in the platform is whenever you're doing a creator update is to return the created or updated record. And then if the front end needs to do something because some operation or mutations occurring in the listener, they will get back that response. And in our case, we're not going to use it at all, but just as a matter of convention, categorize this as like follow the path of most expected. We are going to return the family. So how do we do that? Well, let's write our next test. Returns saved family. Let's go const fam, or let's say created equals await this dot emit save family. Now you see how that's mad at us for two reasons. One, it's typed void. Let's destructure the response from this. Watch. Family. And then I'm going to return family. Now I hover over this. And its type is the 8-bit stories family schema. It's the schema values of it. And that'll be helpful for us when we start doing our autocomplete or IntelliSense, which we are not going to do right now. Right now, what we're going to do is figure out how to extract this so I don't have to do a find one again. Now, one thing I want to do is not just extract the find one, but I also want to ensure that the find one and the thing we're extracting always returns a family. So I'm not having to do all these checks, these null assertion checks. I think that's what they're called. I'd rather just know that the family's there. So if I hover over this, you can see it's like family equals the family schema or null. Well, watch this. Assert dot is truthy family. Now when I hover over this, there's no more or null. So I can get rid of that, and we won't get a type error. So this assert is truthy will remove the nullables in so it's essentially saying a non-nullable. It's a proper assertion in TypeScript. See, assert value is non-nullable, the value of it. So we get back something that is what it says it is. So let's do this. I'm going to extract this here. Control-Shift-R, extract method. Find first family. So the find one will always just return the first record. That might not be the case, what we need in a little bit, because if you think about it, multiple people need to be able to use this. And right now, that's not going to, we're going to have some trouble there. So let's do this. Returns saved family. And then let's go const expected equals await this dot find first family. And then I think we can do an assert dot is equal deep. The created equals the expected did not return family record. Okay, I'm going to rename created function F2 to actual. Yeah, I like that, right? Okay, scroll down a little bit. Did not return family record. Deep equal failed. Actual would need the following changes. I'm trying to pronounce every vowel in a word. So let's take the results here, const created. And let's drop it right here, right? Created. Hell yes. Now we called this event save family, not create family, because well, we need to be able to call this again and also have it update. And I'd rather have one event called save family than one create and one update. And we're going to be able to leverage the source of the event to tell who did it, so everyone gets their own family. But I'm jumping ahead. What we're going to do now is we're going to make sure that emitting the event twice does not create two records. Let's try it. Test. Saving family twice does not create second record. So let's go await this dot emit save family, await this dot emit save family, and let's extract this. Look at this. There's some method. I'm going to make it a little bit useful. I'm going to extract the expected. So extract, let's change it to expected. And then I'm going to wrap this in, watch this. Assert total family records. That is nice. That is clean. And we're just gonna redo it here, right? This dot assert total family records a 1. And that's going to fail because there's going to be 2 creates. There it went. Behavioral family, say family list failed, did not write family record. 2 does not equal 1. Did not write. Let's say this. The correct number of family records. I'm going to set a write. I'm going to say create. All right, let's go into here. How are we going to do it? Well, there's this concept in the data stores called upsert. So if we go families.upsert, the first thing to the upsert is the query we're going to use this to match. If it finds one, it'll update it. If it doesn't find one, it'll create it. But we're not even going to match on anything because we're not there yet. So we're just passing an empty query to upsert. This is only ever going to allow 1 record to be written. Again, this is going to cause some problems when the second family gets involved here. And what, are we all just going to share 1 family record? No, thank you. So let's do this. Test, protected static async, saves different record for different person. Okay. So how do we do that? Well, the faked client is tied to this fake person. So this faked person has a .name, .last name. Everything's done as this person, and this decorator up here, fake.login, is simulating someone being logged in. If we remove this, all these events will be emitted as an anonymous person, which should be blocked because I believe if we go to 8.permissions, we do require logged in. So you will not be able to do anything with your family if you are not logged in. So we keep them logged in, but we do need to emit this event as a different person. So let's first log in as somebody that is not the default logged in person. So I'm going to say const client equals await this people login as demo person, and let's just give them 555 123 1234. Let's just give them a new number. So now I'm logged in. I've got the Mercury client here, right? Mercury client. Oh, look, I got a destructure. We have the person, the client, and their token. Let's get the client out of there. Now we need to emit this event as that person. So we have a few ways we can go about this. I might actually just opt to be somewhat lazy and just replace the faked client with our new one after we emit. So in other words, first thing we got to do is we go await this emit say family. Now we got to be logged in, as another person. So go this faked client equals client. Now let's emit again. And now we should have 2 records. Okay, we're almost at the end here. But now we're going to allow people to have their own family record, and we're going to tie it to their logged in account. So this is we're going to start to tap into the source of an event. So check this out. If we destructure source, and then we go source dot and see here all the sources, we're going to use person ID. If a skill was admitting this, it'd be a skill ID. There's other things, let's say from where an event can be emitted, but right now we're concerned with source.person ID. Okay, so we've got the logged in person, so let's get them out, right? Let's go here, const person ID equals source. But like, what are we doing? How are we going to use the person who's logged in's ID to know to update or upsert the right family record? And the answer starts with our family schema is not done. So this is going to be a test for how well we've extracted the relevant pieces of our code, because if changing this schema is difficult, we didn't do a good job. And I'm imagining there's definitely less than 5, maybe 3 places, max 4 we have to update, but I might just eat my words right now. So let's see. Because again, Anywhere we have to update we didn't expect shows us where we forgot to extract. So let's go to the family builder. And it is the convention in Spruce that you would put information like this in a source field. And so source would contain or hold the person who created the record's ID, or maybe the location they're in, or location you're in would make more sense than a target. So you can check the documentation for how we, by convention, use fields like source and target. In the case of family, though, we're just going to use source to reference the person who created it. So we go person, or no, source is a type schema. It is required. It is, let's go into options and let's go schema. We're going to build schema. I did not spell schema right. We're going to go build schema. We're going to give an ID of family source. And it's going to have one field, and it's going to be a person ID. Its type is going to be ID, and it will be required, not an array. Sweet. So now I'm going to sync events, and we're going to see how good of a job we did extracting. Sync events. Here we go. Ooh, 22 problems. What do you think? I don't think that's right. I think it's just in the middle of building all these files for us. So we'll see where we land. Alrighty, there we go. Down to 6, but we started with 2, so that's 4. And so let's see, command. Let's just follow the errors. The emit payload you passed is invalid. Source is required. Well, we don't want source to be part of what you submit. We want to pull the person off the source of the event that all events, when they're emitted, have. So if you go to the documentation, concepts, events, all events come with a source. We don't want to actually let someone pass a source and then override their own ID and attach a family to someone else, even though that'd be extremely difficult because the IDs by default are MD5s. But either way, we do not want someone to be able to emit the save family event and pass their own source. So let's go save fam builder, and we see we have emit target, which should be empty, emit payload. We're already dropping the ID field. Let's drop the source field. Sweet. Let's sync.events again. Cool. Let's see, where did we land? Okay. Source. Let's go. Save family listener. Create family has one error. Source is required. So this means this create family is a create family schema, and that is probably tied to our data store. But look at this. If we scroll down in here in this call stack, we can see here there's the listener, save family listener, and that is mad. So let's go source, and then there's this. Hit single quote person ID, and let's put in gibberish. That should get us past that. Sweet. Did not return the correct number of families. Okay. So this is going to be a two-stepper here because we need to save the source and then query against it on the upsert. So let's do that. So let's go person ID. And then in the query here, we're going to go target, source. Now we could do something like this, source, person ID, but we're not going to do that because this will look by default in Mongo. This will by default in Mongo require you to have an exact match where all we really want to do is check source.person ID. We don't want to, like, let's say for some reason, I don't know, added a location ID. So they have a different family at different locations. Doesn't make any sense. Go with me on this. Well, this would now just fail because we are doing an exact match on source. So what I'm going to do is I'm going to quote this and do source.person ID and just set it to person ID. Now, here's something there's a few little annoying things here. Is one, this is going to throw a type error because source.person ID is in fact not in the schema. So that makes sense that that's going to throw an error. So I'm going to actually TS ignore that. And then I think that's it. Is that it? Did I make... Did I make the person ID is optional? Did I make the source? What's this look like? Family.builder. Did I make it required? Source is required. Oh, I didn't make, yeah, person ID is required. Okay. So now it's saying save family response. Source is required. So I would expect it to have been in there because it is the full family schema. So what did we do? What are we missing? Families.store. Create schema. Oh, let's, we want the source there. Update schema. We do not want the source there. Database is fine. Okay. I have a feeling, I know. I bet this is an event faker. So let's hit Command KP. There it is. Event faker. I kind of was able to realize that when I looked at the test that was being run. I did not pay attention to the test that was being run, so my bad. It should have been obvious where this was, but instead I looked right at the error message. And it's not the save family and listener test. It's the values skill view test. So I know that this is actually not booting the skill. This is using our event faker, which means our event faker is not done. But again, Command KP should bring us to exactly what's wrong. So let's go source. Cool. Person ID, generate ID. I think that should do it. Okay, that worked. I mean, that's pretty nice, right? We did 2 refactors of our source of truth schema to our family schema, and then got to the point where the amount of changes we had to do to react to and implement those changes was very minimal. So let's go test. Let me go here. Let's go watch.views. Oh, look at that. We need a DB connection string. Now, because this is where you are persisting data. So what we're going to do is we're going to use the DB connection settings that come with the development theater you set up. So we can just persist data and just be done. When you go into a production environment, you are going to want to either point to a production Mongo or check the documentation if you want to see how to do Postgres. For now, we're just going to use Mongo though, because it's super easy and the development theater already set it up for us. So let's go DB connection string, and we're going to just drop in Mongo DB :// localhost, and then the default Mongo. Got it written over here on the side screen. 27017. And then let's save. And let's watch views again. You know what though? Let's set one more thing. Let's go DB name. So we're actually persisting in a database name that we own or control versus whatever the default is. So let's do 8-bit stories. So if we go into a Mongo and we check, we want to check that the records are persisting, we will look in the 8-bit stories database. So let's watch views again. All right, so let's jump over. I'm going to refresh. Let's do family name, family values, hit save. All right, that was kind of uneventful. I think we probably should redirect back to the dashboard when we're done, but let's Command R refresh. Oh, it's not going to populate because we didn't populate it on load. We should do that next. Okay, well, before we do that, let's make it so when you fill out your family name and values and you save, it redirects to the dashboard, which would be right here, to your root skill view controller. More accurately said, I'm gonna close that. Okay, so let's just do that real quick, and then we'll start on the next part of this, which is loading your family on load of the skill view. Let me clean up. There's too many. Cool. I think there's nothing here. Cool. Sweet. Okay. Last bit then. Let's go to values, skill view. Here's the submit. Here's the render. So let's do this. Right in this submit, let's go VC assert action redirects. Whoops. Action redirects. This is going to take a few things. It's going to take an action, which in our case, oh my gosh, is submit. It's going to take a destination optionally, but I want to set the destination, which is going to be 8-bit stories.root. And it's going to take a router so it can look into the necessary components to check if we've used the router to redirect. And we're going to go this. We're going to get it off the views fixture. Get router. There we go. This is going to fail. Should fail. We did not redirect. I expected it to be redirected, but was not. Perfect. Values, skill, values.svc, right? Yeah. Let's go to handle submit. Do you think we have a router in here? I bet we don't. We do. This.router. Cool. So let's go. Do we have a piece in here where we're already routing to 8-bit here? Let's do this. Let's just extract this and reuse this. Yeah. Select it. Extract to method. Redirect to root. And let's just call it in our handle submit, which is right here. Await this.handle submit. Cool. Now when we submit the form, it should redirect. No, I just infinitely looped it. Redirect to root. Goofball. Yeah, I really messed that one up. Sweet. Okay. But as you can see here, we redirected when we should not have. I suspect that the problem here is, do you see how we're filling out the form and making sure it renders an alert? We need to load. So in the renders alert, we didn't actually load the skill view, so the router never got set. So calling redirect to root here on the fail test has our check here. So it just like went right past it. But now that we're loading, look at this. Expected await this.alert to be called in your view within 5 seconds. It wasn't. I was interrupted by this error. You were unexpectedly redirected. So glad we did that to harden our alert test here, right? Because I didn't have load, which meant the router never got set, which means redirect to root never failed. So let's move this into a place where it's only going to run on success. That did it. I'm still, if I hit control space, I'm still, nope, watch. Views, let's watch some views. Cool. Let's jump over. Let's refresh. Let's go family values. Again, we're not loading, so whatever's happening here, I'm just overwriting it. There it was. It's just going to constantly update that record and overwrite what I have. Perfect. All right, dudes. Next step, let's get family values to load at load of the skill view. Populate the form. That should actually go pretty quick. I think it's everything we've done, or most things we've done. Well, we're about to find out. Let's jump in. Let's get this form populated. Firstly, let's jump into the values skill view test. I'm still convinced we should rename this family. We'll do that maybe after this. And we need to do something like this, I think. Test protected static async populate form from get family response. Yeah. Let's do this. Dot event faker dot fake get. We have fake get person. We need to fake get family. We need to just do a was hit check on this. Well, I'm just going to save that, and that's going to get angry because we don't have a fake get family. So let's declare a fake get family. Public async. Let's add a little room to breathe. Let's make the callback optional. Let's just kind of copy what we've done in here before. Event faker.on 8-bit stories. We have say family. Let's do get family. And I can just intuit what this is going to need to return is a family with all the goods. Now, that being said, I don't want to just recreate this data structure because this is another example of where we just decide to change the schema here again. I don't want to have to go to everywhere it's defined. So I'm actually going to extract this and I'm going to do it to a method called generate family. This is funny. Values, which is kind of an interesting name given that we are in an app around family values, but this is the family record. Just to disambiguate a little bit, I'm going to do that, family record values. And then let's do it in here. This dot generate family, generate family record values. Cool. So now we go back. Let's get our was hit type error here equals false. Let's load. And let's go assert dot is true. Was hit. You didn't emit the get family event. Well, that's not great. I mean, it's not great. Why is this? I think it's unused. There it goes. Yeah, VM's not the fastest. All right, you didn't emit the get family event. Let's do it. Let's go to values SVC. Inside of load, not much going on here. Const client equals, oops, wait this dot connect to API. Wait client, emit and flatten 8-bit story. Say it's not save family, get family. We're emitting it, so let's see. The event 8-bit get family was not found. That means it's time to create it. Look how many tests it failed too, because every test that we're calling load is now going to fail because it's loading every time. And it's not wrong. Get family doesn't exist. It's control space. We're already watching. When we control space and restart that task and go create.event. And we're going to call it get family. Its event name, kebab case, is get family looks totally fine. The camel case name is get family looks fine. Just we're going to keep using this same version. If we ever need to do a major breaking change and other skills depended on us, it might make sense to start a new version so they could get legacy support, but that's not helpful for us right now. Okay, well, while that's going, let's go into events and let's go get family and let's go emit payload. We're not going to need a payload. Let's go emit target. We're not going to need a target. Let's go event options. It is global because, again, it is not scoped to a location or an organization. That, again, is just due to the multi-tenant nature of this platform. When you're ready to monetize and sell a skill to a business, you can set it to require installation at that business and through the marketplace, require them to pay you for it. In this case, though, we're just making this available, and so we're going to set to global. I'm going to go into the save family. So do you see how we have this emit permissions? Let's just retype it for the sake of the muscle memory. Emit permissions. So by default, the skill that created it can emit and listen. We want a logged in person to be able to emit this. So we go build permission reference. It takes the 8-bit stories. Now it's called 8-bit stories dot 8-bit stories because the skills namespace is 8-bit stories and the permission contracts ID is 8-bit stories. As you would imagine, this will let us in the future have multiple permission contracts per skill. We just won't need to leverage that this time. All right, can manage family. That's it. And then what is the response? I think the response is family. So let's go type schema. Let's go is required true. And then inside of options, let's go schema. And let's just, now we're going to point it to the family builder because we're in a builder. So we're not even, again, we're not in production code. These builders are used to build the production code. So again, you do not want to go family schema because then this template for building the schema is using a built schema, and that gets really tough if something doesn't work out exactly how you want. It can't reference a thing that's not built. It can't build because the type is the built thing's not built. It becomes a major mess. It's the equivalent of the equivalent of recursive dependencies. It becomes very painful. I think that's it though, right? Response payload of the get family, trace a family or event. Its global is true. We're gonna ensure that a logged in person can emit it. So if I went to 8bitstories.permission, see here's that ID I'm talking about. There, can manage family defaults to logged in true. Now it's default in here. If you recall though, there's this thing we call an authorizer status where we can actually only give someone permission if they're clocked in, clocked out, if they're off premise or on premise. So using the Wi-Fi skill that we can detect if someone's actually on site and only give people on site permission. Again, this is really only useful in the context of scoping our work to an organization or location, but just wanted to show that again. Sweet response, bam. I think it's good. Let's run sync.events. Let that finish. Let me just go clean some of this other stuff up. Cool. Done. Let's go to our test file. I don't expect it to fail as hard. Maybe it will, because look, we are calling load in all of our tests. So look at this, go open. And it's kind of telling us like, hey, you're emitting it, but you got to handle it. So we either create a listener for our skill and boot the skill, or we use the event faker. And we're just going to use the event faker. So I'm going to do is I'm going to move this up to the before each. And then now, and I'm not even going to pass the callback. Now, all those tests that were passing before will pass again. All right, you didn't emit the get family event. Well, did we load our skill? And this is called get family. Bitstories.get family. Okay, let's go to values.svc. Load. Call get family. Did I do a check wrong? Was hit. Fake get family. Now we're not loading up here, right? I'm missing something obvious. Oh boy, this is going slow. Did I not? Oh, look at this. Dummy. Yeah, it's always something obvious. I forgot to invoke the callback. Now, when the listener gets hit, it invokes the callback. The callback will then set is hit to true. Okay, now we want to have whatever the results are from fake get family return to and set in the form. So let's do this. Let's do const results. And then what is this? This is just going to be a family, right? And I don't even think I need to type this. Let's do eventfaker.generate. Oh, look at this. Remember we did the generate family record values? Let's make that public. Because I don't want to have to go fill all that out again, right? And we don't need this type. It's going to be able to infer the type from here, right? Oh, that's just a type literal. Like a reference here. Family. Right? Yeah, so now if it ever changes, we'll get the error where we want it. So I'm going to just call this family, I guess. So what I want to do is I want to return this family. So I know what the values are, right? Not the family values, but the values of the record. That's confusing. All right, let's go to get family. So let's make this callback return void or a family. And then let's in our response do a little null assertion like that. And we'll say if the callback returns anything truthy, anything not null, or I think it's anything truthy, No, I think undefined, this is only null. This is a null assertion. So if the callback returns anything, use it. Otherwise, fall back to generating random values. So I should be able to hit save. Now I should be able to get the values off the form and check them. So let's do this. Const actual. Well, let's do this below this assertion here. Const actual equals this dot form vc dot get values. And let's go assert that is equal deep actual. And the expected is name family dot name. Whoops, that's not a dot. And values family dot values. That's my who's the guy from Batman? You merely adopted the dark. Values not set to the form. And not wrong. It definitely wasn't. So let's go set it. So let's go values svc. Let's take the first response for this. So if you recall, we have the ability to allow many skills to listen to an event if you set up the permission contract that way. And there are just some cases where I'm destructuring the family out of the first object and the first results, the first response, because we're only going to have one skill listen to this. But there's times where you want to emit an event and you want a bunch of people to respond, and then you want to iterate over all those responses and do something. In this case, though, not the case. I guess in this case, not the case. Let's go await this dot form vc dot set values. I guess let's set family. Why is that? Yeah, it shouldn't be mad at us. I imagine that should work. Sweet. It should ignore the fields that aren't relevant. So we're only setting values. So right now, just name them. But, if we went and, let's say, change the fields that are visible, those would be populated also. All right. Let's clean up this. Let's clean up this a little bit. Let's clean this up a little bit. Let's get rid of the was hit check. That's redundant now that we're doing the equal deep. I think it's time to implement our get family listener. Well, what are my type issues? Command KP. Get rid of that. Yeah, that should do it. Cool. Yeah, let's create so control space, create test, behavioral test, get family listener. Get family listener. And we're going to put it in our family directory, and we're going to just extend the abstract 8-bit test. Sweet. So let's go here. We've got our first failing test, which is not even really valid. We're going to say skill is listening. That's kind of always the first test when you're in your listener test. We just want to make sure the skill is listening. And then let's say in a case where we're trying to let's say if we ever tried to get a family, but we wanted to target it by ID. So like maybe once we start giving people the ability to add people to their family, this skill is listening test could turn into very quickly a throws not found error test. But anyway, my point is start with skill is listening, and then if you decide that you want the first behavior to actually be throwing an error, like a not found error, then modify the test. Looping all the way back around to that idea that you cannot tell how someone built something by looking at the tests, because it's like a journey. Let's do this. This dot event faker. No, baked client dot emit and flatten get family. Oh, come on now. 8-bit stories dot. Let's get family. This is going to throw an error, something along the lines of must be handled locally. Make sure you've created a listener using Spruce Create Listener and have booted your skill using await this.boot skill, or use the event faker. Well, we do not want to use the event faker because we're actually testing the listener. So let's control space. What is it saying? Create.listener. And let's go get stories. Get family. Cool. Let's go back to our test. Sweet. Not sweet. Almost sweet. We need to go to get fam.listener. We need to not throw a listener not implemented. I'm going to cut that. I won't need that spruce error. There's like no way this is going to error. Okay, response payload family is required. Okay, I have a question. What if someone doesn't have a family? Maybe family shouldn't be required. Maybe the first time you go here, we call it get family. If you don't have one, it returns null or undefined. In this case, there's technically is a very important difference between null and undefined. Imagine that we were updating a record. If a field is undefined, we skip it. If a field is null, we actually set it to null. And that's important distinction. Not relevant here. In this case, I guess the question is, what should happen if they don't have a family record saved? And I think it should return like falsy. It should just not even return something like this. Let's do this. Let's go to get family response builder. And let's make family not required. And then let's go sync.events. I wonder if that's going to cause problems in another test. I bet this is going to introduce an interesting situation. Because in our in the get family event in the values skill view controller, it definitely did expect to return something. We'll get to that. Let's see. Cool. I'm just going to return empty object. I think that will get rid of the type error there. Sweet. We're not using event yet, but we'll come back around to that. Okay, let's do this. Test. Protected. Whoops. Static async returns only family record. Okay. So there's a few ways that we could go about this. We could like boot the skill, emit the create family, then emit the get family, and see if it returns the same family. But we're not going to do that because that kind of gets into the territory of we're testing things. We're like testing the save family. We don't want to do that. We could do something like this. Await this dot families dot create one, and as you can see, families is not set because I think I forgot to move that store into the abstract tests, which we are going to need here. So we're going to move that in a second, but I don't want to do that either. I want to use the seeding functionality that exists in the test framework. So I'm going to go seed, and then you see in there's families, but there's some other stuff in here too. Look, group managers, guests, locations, managers, organizations, owners, teammates, in this case, families, and we're going to just seed one family. Uh-oh. The families store you created needs a method called seed options, store seed options in order for seeding. You must implement it yourself for now. It would be kind of cool to have it auto write that piece for us, but it's easy enough. So let's go family store, and let's just write real quick. Let's write the logic to seed a family. So we're going to go public async seed its options, store seed options. And then look what's in options. We have two things. The test class. So we're actually going to get our test class here. So we can actually access the things that are helpful that we've done in our tests. We're going to need this for in a moment. And we also have total to seed. And it goes like right here. So this tells us which store to load. This is total to seed. And we're going to get into other things we can pass in a second too. This is cool. So let's jump into the family store. Let's just make this work. So I'm going to go const total to seed, and we're going to pull that out of options. And then in order for this to work, we actually need to seed it with the logged in person as the source. You hear what I mean? Like if we just randomly put in a person ID in the source that's not the person who's logged in, then that we would expect that listener not to return anything. But that's not what we're testing right now. What we're testing is that it does return something. So I need to seed it with the logged in person's ID in the person ID property of the source property of the family. Okay, I said all that and it sounded like a lot. It's really not. So let's do this. Const person ID equals test class dot faked person dot ID. So if you recall, this test class is this class right here. So not only do we have access to all of our fixtures and all of our faked data, but we also have access to things we want to put here, like our event faker, which we're not going to use. which is available to us. Who is that guy? Bane. Got it. That was hard to remember. So let's do this. Await promise.all array.from. And then I think we just pass it a length is total to seed. Then let's go map. We're not going to actually want to take in any of the properties from that callback or the parameters, because that's just like its index number or current item, and we don't care about any of that. We want this dot create one, and a name is generate ID. The values is generate ID. So in this case, you notice I used generate ID. So let me just finish typing this up. Generate ID. Well, okay, it already imported. So up here, you see there's generate ID in the data stores. But if we go into our tests somewhere, I'm going to be able to show this to you. Well, let me just type it here. There's generate ID in the test utils. These are mostly interchangeable. They are implemented differently and do behave in slightly different ways. And so in the data store, instead of importing a test util, I'm going to import a generate ID from the data store. I can't defend that, so maybe that's dogma. Let's see. This is gonna get really mad at us though. Good news is only in that one test, because that's the only place where the seed decorator is being used. Let's see. Source is required on create family, has one error. Cool. So source. And again, we want the source to be the right person. So now we've seeded a family. If you notice, if you went seed and tried to seed two families, we'd get two families with the same person, which would technically be a violation of our family rules, which reminds me, maybe we want to put a unique index on source.person. Yeah. Let's do that real quick. So if we go here and we implement the initialize function, let's go public async. We can go this dot, it's going to be another async, this dot db dot sync unique indexes. So remember I was telling you there's that database object that you have like in your listener. So if we went get family.listener and we went event.database. Now this only exists because we installed the database feature the first time we created a data store, the data store feature. This is what's going to allow us to have direct CRUD access to the database without schema validation. It's very raw. Don't use it often. It is though useful for running a custom query, which when we go in to get into running like Postgres queries and needing it to be more complicated with joins and stuff. Again, we're not using an ORM, just like write the query, test against it, wham bam. All right, sync unique indexes takes the collection name, which is this dot collection name. And you can think of collection name, it's using the Mongo lexicon, but this is the table name. This name is not tied to anything arbitrary. And okay, enough of that. Let's create our unique index. So unique index is a few things, or is an array of indexes, and an index can be two things. It can be an array of strings or a filtered index, which looks like this. So you can actually apply a unique index, but then filter where that unique index applies. And that is way more complicated than we need. Right now, what we need is just this is a field name. And again, an index is not a string or a filtered index. An index is an array of strings, because this index we might want to create a unique index on two fields joined. In this case, I don't. I just want to go source.person ID. So that's going to create a unique index on the person ID. Now, you noticed I didn't write a test for that. Let me try to defend that choice. Something like the configuration of a database, I don't want to test in the software. I can't say that necessarily that's a good defense, but having worked a lot in Mongo and a lot with Postgres, and having used this with some companies, it's asserting that a unique index exists has not been useful. And also, when we've worked with Postgres databases, we actually don't create our own index. So this would create an index on the boot of the skill, but when you're working with DB admins, they do not want you creating an index, and honestly, they also don't want you creating tables and fields and columns and blah, blah, blah. So that's why we just don't get into the business. And this data store layer makes collaborating with database admins really nice. And again, because you can just implement their opinions in the database schema and map it to a schema that's actually useful for programming. Okay. Where were we? So we did source person ID. Let's test this just so I can prove to you it works. Again, good case to be made. Well, shouldn't you have written the test for it? It just is. Maybe I can just generalize it too. It's never bit me doing it this. Like, I've never. Oh man, I wish I wrote a test for that unique index. And then they change, they get updated, and I just don't want to have to go fix tests. But the tests do honor them. So in other words, look at that. One or more families already have the source.person ID, blah, 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 you provided. So the tests are going to honor those unique indexes, which is super helpful and nice. So returns only the only family record. All right, let's come back up here. Let's go protected. Whoops. Protected static async before each. Await super dot before each. Let's move the boot of skill to the before each. I do not want to have to emit again. Just in this case, using the heuristic, every dot in an invocation is an exponential increase in difficulty of refactoring. And I want refactoring to be easy, because if we're about ready to go like rename a skill view and move it to a new place, because I don't like that I named it families or values. It should have been named families. But that's the thing about this kind of TDDing approach and using these tools is like we're not stuck. We're gonna be able to rename some things, remove it, rebuild, and then our test should pass. We're about to find out. We're not about to, but we will. All right, so let's do this. Emit get family. And I want something like this. Let's destructure the family object out of the first response, because again, we're only doing one. You see, it's optional, so that came back with the question marks. And let's just check if it's truthy. Const actual equals await this dot emit get family assert dot is truthy actual. You did not return a family. Now that's a nice little stair-stepper test, yeah? Because what we really want to do is compare it to the record in the database. Now, I might have mentioned this, but I don't recall if I did. In the tests, we're using an in-memory Mongo. What do we call it? It's an in-memory Mongo implementation. It's called NEDB. They implemented the interfaces that Mongo uses, at least most of them. So that's how we're able to write this stuff. Now, again, the way that data store layer works is if you were to, for instance, enable Postgres, you configure the Postgres adapter. That right here, look at this. This .db is a database object right here, database. I don't hold these typing things against me. This database right here, though, in a test, it's an instance of an NEDB database. In production, because of the way we have our connection string set up, it's a Mongo database. If we were to configure Postgres, this would be a Postgres database instance, and it would use the Postgres database would handle mapping these objects that we're passing into queries. So like this would be in the Mongo database adapter, would map to an insert into collection name set, and then key value, so generate the query for you. But again, too, also when you are ready to do some more sophisticated database querying, just run the raw query, and then nobody ever has to regret being tightly coupled to an ORM, which are the devil. It's one of those things that, to kind of be less dramatic about it, ORMs are the type of thing that work until they don't, and then you're hosed. And then you end up, in a lot of cases, just writing raw queries anyway. And so it's just, if a case can be made to bring an ORM in, you could do it. I don't have to be the one that does it. But I think once you just get the hang of the data store layer and you're just running simple CRUD operations and you're using schemas, you're just going to find that ORMs it's just not helpful. Okay, so we didn't return a family. That is not great. Let's do that. Let's go get.listener and let's pull out this store. So const stores this event. If I hover over that, that's going to be the store factory. Let's get the families store out of it. Wait, stores dot get store families. And let's load one. Const match equals await families dot find one. No query, return family match. Right? That's gonna work, right? Cool. We do have command KP. All right, that's mad. Oh, yep, that's what we were talking about earlier. Now that it's null or undefined, this really, 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 really wants it to be something, or I think null, right? No, it wants something. So the test passed though, because this technically would not fail. The form VC is not that fragile. Like it's okay that you pass it nothing, but the typing doesn't like it. So we have a few options. We can TS ignore it. I don't think that's a good idea in this case because there is value in the typing that is here because essentially we are using set values in a way that is not recommended. Again, it can handle it, but it's not recommended. That's why the typing is the way that it is. So I kind of think the two options are one, do an if on the family, just a truthy check if family, or we could do a null assertion and so pass the empty value, empty object. But, it doesn't matter from a test perspective, and I doubt there's much of a performance implication. But let's just say that one of our values is don't run things we don't need. Let's just wrap it in an if, and that will get the types to pass. It is immaterial. It's going to run and all pass just the same. But now we can feel better that our types are passing in a place where, and that has resulted in us not running code we don't need, avoiding running code we don't need. Yeah, I think that made sense. Sweet. Okay. Should we make sure that the family actually exists the right thing? Because look at this. I messed this up. Watch. Could I do something like this? Oh, that'd be a pain in the ass, though. No, I'm not going to do that. Not going to do that. Let me just be a jerk and fake this response. Watch. If match, return family. You don't have to do this. You could just watch. But it really, like, imagine how, our tests are going to pass, right? Like, how is it not fragile, but like, just how risky is that like we weren't actually testing the response, that it equaled what we thought it should equal. So it was a little bit more work to truly fake it this way. And one thing Bob Martin talks about is like not going for the gold. And so I think in the discipline of TDD, we should have returned a really bad response to start. I didn't. I just returned the family. I do think that was a bad move because, geezy, I was just able to go in here and fake a response. Now, I had to add a lot of code to break it in the way I knew it would break. So it's like very low probability, but like imagine if someone accidentally was in here and like fat fingered and overrode the name that was being responded, that was in the response. Like not awesome. Okay. Now let's actually test the database. and against the record in the database. So let's go const expected equals await this dot get first family. Famille. Okay. So if you recall, we did some extraction in a different test, and I don't want to have to go do all that again. And this is a good use case for moving up some functionality into the abstract 8-bit test, or the abstract your skills namespace test. So I'm going to double click on this, or click once, hit Command D. I'm going to hit Command Shift F. Didn't I have it as find and get? Oh, it's find first family. Right? I think it should be a get. I think it should be get first family. So first thing I'm going to do is, and the reason why I say it should be get first family is because that's what I intuitively just did. So let's command click on this. Let's cut this. Let's go back to here. Paste. Protected. Whoops. No need to make it public. That's going to get mad at us because we don't have families in here. Let's declare the property. Let's call it protected also. Nice typing, VS Code. I mean, actually, I think that's TSC, right? Look, assert's not included. Command period and test utils. Assert is in test utils. This is the one you want if you want one that's tested to this level of thoroughness, which I do. I guess technically you don't have to. All right, so this is mad at us. Static side type of this incorrectly extends base class. These errors are not helpful, but I know what it is because I just did it. It's the fact that we have families defined here privately. We have families defined here statically. And if you think about it, we actually just don't even need that. That should fix that. That allowed us to remove an import from our test. And there is some heuristic also around more imports means more difficult refactors. And so it's really nice when you can really cut down on the number of imports you need. All right, here we go. Assert.is equal deep. The actual, the expected, nope, expected, and did not return the family record. Cool. There it is. Look at all that. Yeah, cool. So let's go get family. And now let's just do it how we did it the first time. Family equals match. Cool. We're almost there. Last piece of this test is we need to make sure it pulls the right family. But interesting, this should actually work. We should be able to go watch views, and we should now be able to pull up the skill view and have it show our record. The family is now persisting. It just so happens if I log in as someone else, I'll see the first person who ever did anything's family. Even though when I'm saving my family, I am saving one specifically for myself. So let's go refresh. Okay, refresh. Refresh. What's going on? Did the watch not work? Oh, I've got two watchers. Shite. Okay. Watch.views. Okay, so that's an interesting situation. I had watch views running twice. I had must have just manually run it. The reason why it wasn't populating is because if we go into values.svc and we go to load, we're taking the first response. But what was actually happening is because we had the 8-bit story skill booted twice, it was getting back 2 responses, and I bet you the one we wanted was in the second one because the first one was just sitting there. And watch views does not reload the back end of your skill. So all those additions we made to the listener would have not done anything, and it just so would have returned nothing, or whatever state it was in when we watched it the first time. Now, you might be able to make a case, I did not mean to do that. You might be able to make a case that we should not allow the same skill to be booted twice, but then how do we scale horizontally? I don't even have an answer to that yet, but I don't think that we're going to want to limit the number of times a skill can connect. But maybe we will. The future will tell us. There it is. Let's go. Family name, values. Let's do family values. Sweet. Back to family values. Right on. Okay, let's do some things here. So next we're going to, I want to drop in a header image, just give it some style, and then let's do our refactoring. So first, real quick, let's just drop in that header image. I have one in my clipboard. You're allowed to use it. Totally. Where's our card? Here it is. Title, your family. Image, right? Yeah. Here it is. This is very presentation-y, so I am not going to test it. I believe if I hit Control Space, I am still watching my views. Perfect. Building differences. Let's go back to test. Sweet. I mean, those are better pass. Okay. See, again, these deprecation warnings, I am going to go fix that in between our next chapters. Something just updated and became deprecated, but I don't know where yet. All right, refresh. Yeah, that's cool, right? Nice. Okay, next up, let's rename the value skill view family. Let's move these events and listeners into the right folder named after the behaviors that categorize them, and then we'll move on to the next chapter. All right, let's do it. So where to start? Again, we have a few things where you want to move these events and listeners into the directory that best represents the behaviors. We want to rename the values skill view to family skill view. We'll probably actually also change its ID so it, and then instead of redirecting to 8-bit stories.values, we'll redirect to 8-bit stories.family. So one thing at a time though, let's start with moving our events and listeners into a family directory here. So folder, family, and then I think these are family related events, so I'm gonna drag them there. And then listeners, whoops, import updates, yes. Update imports. Listeners, 8-bit story. So I'm going to go into family, create a new folder, listeners, and I'm going to drag the 8-bit stories directory in there. Cool. What else? Store. Let's put the store in family also, right? It's values. That's family values, which is going to be renamed shortly. Okay, so that was a lot of dragging stuff around. So let's make sure our generated files still work. So first thing I'm going to do, Control Space, I'm going to call sync.listeners. This is going to update all the references. And yeah, look at that. Updated the listeners.ts, which is actually, I'm going to go take a look at that. Watch. I go to .spruce and then events, right? Listeners. And here are all the listeners. So this file gets generated. And then when your skill boots, this is the file that the events feature uses to know which listeners to load. And this requires cache, so it doesn't actually run it twice, but we do that. We have to import 2 pieces to it. Anyway, cool. So now let's run sync.events. Now, this is a little bit different than listeners because the event files are all builders, pretty much. And so there's actually no references in production code to any of the events. So this should be immaterial, this thing here. Nothing should change because, again, the builders are just the template files. But it looks like some import did fail, which is why we do want to at least try. Import says family events, get family, response payload builder, error. So look at that. Cut. Import. Let's run sync.events again. Got another one. Looks like the save family. Let's cut that. Import. So someone will have to answer to me why when I moved the files and told VS Code I wanted to update the references, it didn't do it. I have no idea. And sometimes it does do it, is the thing. So anyway. Almost there, right? guess I could go look at the problems tab. The thing is, though, is until we get this working, the problems we're going to face, yeah, look, are all over the place because these files failed to generate. I expect those errors to go away. There it is, generate value types. Cool. Bam. So our events contract update is, let's go look at that. Look, no more problems. So let's go .spruce events contract. So here are all the contracts from all the skills we depend on, which is actually Heartwood is the only one. Here's it mixing in the core event contracts. And then you can see here is our type. We used declaration merging to make our typing consider all of our dependencies. And so like 8bitstories.getFamily points to this type. Here I can command click on it and jump here. This is going to be mad at us. Why? Because I can't find it. I don't believe it. I think we're just outside of the things. I think VS Code does not handle things in the .spruce directory well by the way we've configured it, because we don't want the things in there type checked. Okay. So that was good. Now let's rename values skill view controller to family. Ready? So this might be a good place in principle to commit, but I don't want to do that because I'm going to commit. I got to move to a new branch for the starting chapter. And so I think if you're on your own project now and you're about to do these types of refactors, it is always just useful to commit before you do it. For the sake of this documentation, though, I can't commit it until I update the repo, and I haven't created the repo for the next chapter yet. So step one, let's go values. Let's rename this family. Then let's go to ID family. Then let me go function F. Yeah, let's see. I don't know if this it's asking me if I want to update the imports, but we've already demonstrated that does not work. Totally. It works in some places. So we're going to go function F2, rename this family. Now it's not going to blow up entirely yet. A little bit. We need to blow it up a little bit more. So we're going to go sync.views. And there it is. Now I expect things to be mad at us. And look, 3 problems. So if we went to here, just go back to terminal. That's not wrong, right? It's now .family. .family. Okay. Spy values is now function F2. Spy family. And then if we hit command KP, handle click family values. Well, that's not going to work because it's now family. Command KP, I think that's it. It looks like it's it. There we go. Another one here. Let's see. I expected to redirect it to values, got redirected to family. Well, this is a case where fixing the type in the production code is showing us where we've got an issue in the test code. And this ID does not look, this is typed as a string. I might change that actually to type it as a skill view controller ID so you get autocomplete on it. But I think that's it. Almost it. Let's do something else here. Let's go into test behavioral values and let's take this test and drag it into family. And let's rename it family. Then let's go up here and function F2. It's always good to just function F2 rename any of your class names, method names, anything like that. So that does seem to propagate pretty consistently. Let's get rid of this values directory in our tests. And let's go mirror that in our production code. So we go to values and we have family, but it goes in our family code. Family. Okay. I don't trust VS Code again, so I'm going to run sync.views. Nice. See, and it still updated the file, which meant VS Code did not update imports. So if I hit Control Space and I go watch.views, We should get a built skill views, waiting for changes. Watching for changes. Cool. Reload. Family values. I mean, we're not going to see anything, I guess, because we don't see the URL. But let's do this. Let's go to Safari. I go create a new tab. I'll go localhost 8080. And then you see how it says a heartwood.root. We're going to go 8bitstories.root. It's going to make us log in. Cool. Let's go family values. Yeah. We don't have members. Cool. Sweet. Okay. Just wanted to show that to you. Okay, that's it. We successfully created the family skill view to manage our family's name and our values. We managed some redirects and then did some refactoring and updated our redirects. We rendered a form. We registered a few events, one to save, one to get. But wait a second. Oh my gosh, we're not done. Look. For those of you watching along, you must have been yelling at me, right? We need to make sure that we're only getting the family that's the right family. Jeez, dudes. All right, let's go do that. Let's go get family.listener. Get family listener test. And then let's do this. Test seed families should set faked person as source equals false. Protected static async returns family tied to logged in person. And it should be something like this, right? Constant family assert.is falsy family. You returned a family and should not have. Okay. Oops, I meant to keep that as 1. There. So now we're seeding one family, but we're passing some options we have not yet implemented. So this is going to throw an error. There it is. It's not falsy. You returned a family and should not have. All of that is not falsy. Correct. So let's go into our family.store. Let's go to our seed method. And let's do this. Seed. I don't know what to call this, actually. Let's go with just seed options. I guess there's an option. It's not a good name. We'll come up with one. And then let's copy this. Should. And then this is a Boolean. This is optional. This is optional also. And we'll say const. Let's do this. Seed options. Oops. And let's fall back to an empty object, right? And say should set and default this to true. So should set faked person as source, yes, or generate an ID. There we go. Maybe I don't know what to call this. I never know what to call this specific one. It's called custom. Bad name. Someone's got a good idea for a name. I am all ears. You return a family and should not have. Fine. Get family.listener. We're going to go source. We're going to destructure the person ID out of the source. And then in our find one, we're going to go quote source.person ID. Person ID. That should do that. I know a little nuisance is going to get mad at us because source.person ID doesn't work. I've attempted to get the typing to support dot like that, and that just wasn't possible when I last tried, but TypeScript sure has updated a lot, so maybe that works now. That worked. Let's TS ignore this. Perfect. We're warning free, error free, functioning end to end. Reload. My computer is dogging. Oh, running this in a virtual machine is suboptimal. Sweet. All right. What do we have next? Next we have family members. Cool. Now we get to a lot of the same stuff. There is a form, there's loading and saving and things like that, but we get to start playing with some more UI elements. In this case, a list. All right, dudes. See you there.